Hidden in plain sight, ancient wonders whisper secrets of a forgotten world. The Great Pyramids of Giza stand as colossal monuments to human ingenuity, or perhaps something more. For centuries, these massive structures have captivated imaginations and confounded experts. How did ancient Egyptians, armed with only copper chisels and wooden rollers, build such precise and enduring marvels? Some theorists propose a shocking alternative: advanced technology from a lost civilization. They point to the pyramids' uncanny precision, with blocks weighing up to 70 tons fitted so tightly a knife blade cannot pass between them. The inner chambers align perfectly with celestial bodies, suggesting deep astronomical knowledge. While mainstream archaeologists dismiss such claims, citing evidence of gradual architectural evolution, the debate rages on. Could these ancient stones hold the key to unlocking humanity's forgotten past? As we peel back layers of history, the truth may be more extraordinary than we ever imagined. The Great Pyramids of Giza are ancient monumental structures located on the outskirts of Cairo, Egypt. These colossal tombs were built during the Old Kingdom period of ancient Egyptian history, roughly 4,500 years ago. The Giza Pyramid complex consists of three main pyramids, with the largest and most famous being the Great Pyramid of Khufu, also known as Cheops. Standing at a height of approximately 146 meters, the Great Pyramid was the tallest human-made structure on Earth for over 3,800 years. It was constructed using an estimated 2.3 million limestone blocks, each weighing an average of 2.5 tons. The precision and scale of these structures continue to astound archaeologists and engineers to this day. The other two main pyramids at Giza were built for the pharaohs Khafre and Menkaure. Together with the Great Sphinx, a massive limestone statue with a lion body and human head, these monuments form one of the most recognizable and iconic sights in the world. The pyramids were designed as elaborate tombs to protect the pharaohs' bodies and possessions for the afterlife, reflecting the ancient Egyptians' complex beliefs about death and the journey to the next world. Despite centuries of study, many mysteries surrounding the construction of the pyramids remain unsolved. How exactly the ancient Egyptians moved and placed such massive stone blocks with remarkable precision continues to be a subject of debate and research. The Great Pyramids stand as a testament to the ingenuity, ambition, and architectural prowess of one of the world's earliest and most fascinating civilizations. The Great Pyramids of Giza were constructed during the Old Kingdom period of ancient Egypt, specifically in the 4th dynasty. This monumental undertaking began around 4,600 years ago, with the first and largest pyramid, known as the Great Pyramid of Khufu, believed to have been built between 2,560 and 2,540 before the Common Era. The construction of the other two main pyramids followed in relatively quick succession. The Pyramid of Khafre, the second largest, was built around 2,520 before the Common Era. The smallest of the three, the Pyramid of Menkaure, was completed around 2,490 before the Common Era. These precise dates are the result of extensive archaeological research, including radiocarbon dating of organic materials found at the site and analysis of ancient Egyptian historical records. The construction of these massive structures spanned several decades, representing an extraordinary feat of engineering and organization for the ancient Egyptians. The time period during which the pyramids were built marked the peak of pyramid construction in ancient Egypt. After this era, the practice gradually declined, with later pyramids becoming smaller and less elaborate. The Great Pyramids stand as a testament to the advanced capabilities and ambitious vision of the ancient Egyptian civilization at its height. The construction of the Great Pyramids of Egypt is traditionally credited to the ancient Egyptian pharaohs of the Old Kingdom period, particularly those of the 4th dynasty. Khufu, also known as Cheops, is most famously associated with the largest and oldest of the pyramids at Giza, often called the Great Pyramid. His son Khafre is believed to have built the second largest pyramid at Giza, while Khafre's son Menkaure is thought to have constructed the smallest of the three main Giza pyramids. These massive monuments were not the work of the pharaohs alone, of course. They required the labor and expertise of thousands of skilled workers, architects, and craftsmen. Recent archaeological evidence suggests that these workers were not slaves, as was long believed, but rather paid laborers who took great pride in their work. The construction of the pyramids was a monumental undertaking that showcased the advanced engineering and organizational skills of the ancient Egyptians. It is estimated that the Great Pyramid of Khufu took about 20 years to complete, using approximately 2.3 million stone blocks, each weighing an average of 2.5 tons. While these pharaohs are traditionally credited with the pyramid's construction, it is important to note that our understanding of ancient Egyptian history continues to evolve as new archaeological discoveries are made. The full story of how these incredible structures were built remains a subject of ongoing research and fascination for scholars and the public alike. At the Giza Plateau in Egypt, there are 3 major pyramids that have captivated the world for millennia. These colossal structures, built during the Old Kingdom period of ancient Egypt, stand as enduring testaments to the ingenuity and ambition of their creators. The largest and most famous of these is the Great Pyramid of Giza, also known as the Pyramid of Cheops or Khufu. This monumental edifice was constructed for the pharaoh Khufu and originally stood at a height of 146 meters, though it has slightly diminished over time due to erosion and the removal of its outer casing stones. Adjacent to the Great Pyramid stands the Pyramid of Khafre, built for Khufu's son. While slightly smaller than its neighbor, it appears taller due to its position on higher ground. The third major pyramid at Giza is the Pyramid of Menkore, the smallest of the trio, but still an impressive structure in its own right. These 3 pyramids form the core of the Giza necropolis, a complex that also includes smaller satellite pyramids, the Great Sphinx, and various temples and tombs. Together, they create one of the most recognizable and awe-inspiring archaeological sites in the world, drawing millions of visitors each year to marvel at these ancient wonders. The pyramids of ancient Egypt were primarily built as monumental tombs for the pharaohs and their consorts. These colossal structures served as the final resting places for the rulers of Egypt, designed to protect the pharaoh's body and possessions for eternity. The ancient Egyptians believed in an afterlife and that proper burial practices were crucial for the pharaoh's journey to the next world. Constructed during the Old and Middle Kingdom periods, the pyramids were not just tombs, but also served as symbols of the pharaoh's power and their connection to the gods. The pyramid shape itself was significant, possibly representing the rays of the sun spreading down to earth. This design allowed the pharaoh's spirit to ascend directly to the heavens. Inside these massive structures, elaborate chambers and passageways housed the pharaoh's mummified body and a wealth of treasures and provisions for the afterlife. These included food, furniture, jewelry, and even boats for transportation in the next world. The pyramid complexes often included smaller pyramids for queens, as well as temples and other structures for ongoing rituals and offerings. The construction of pyramids was also a way to unite the kingdom, requiring immense resources and labor. This process reinforced the pharaoh's authority and the social structure of ancient Egyptian society. As such, the pyramids served multiple purposes: preserving the pharaoh's body, ensuring their immortality, demonstrating their power, and maintaining social cohesion in life and beyond. The Great Pyramid of Giza, one of the most iconic structures in human history, stands as a testament to ancient Egyptian engineering and ambition. Originally constructed to a height of approximately 480 feet, this colossal monument has weathered millennia of wind, sand, and time. Over the centuries, erosion and the removal of its smooth outer casing stones have reduced its current height to around 450 feet. To put this into perspective, imagine a modern 45-story building rising from the desert sands. The pyramid's immense scale becomes even more impressive when we consider it was built over 4,500 years ago, using only the tools and technologies available to ancient civilizations. The Great Pyramid's height is not just a matter of physical measurement, but also a reflection of its builders' precision and skill. The structure was designed with incredible accuracy. Its sides aligned almost perfectly with the cardinal directions, and its height calculated to create a specific geometric ratio with its base. This monumental height allowed the Great Pyramid to hold the title of the tallest human-made structure on Earth for nearly 4 millennia, a record only surpassed in the 19th century with the advent of modern construction techniques. Even today, as we reach ever higher into the sky with our skyscrapers, the Great Pyramid's stature continues to inspire awe and wonder, serving as the enduring symbol of human achievement and the grandeur of ancient civilizations. The Great Pyramid of Giza is a colossal monument that has captivated human imagination for millennia. This ancient wonder weighs an astounding 6 million tons. To put this enormous mass into perspective, it is equivalent to the weight of 15,000 fully loaded Boeing 747 jumbo jets. The pyramid consists of roughly 2.5 million individual limestone blocks, each weighing an average of 2.5 tons. Some of the largest granite blocks used in the inner chambers weigh up to 80 tons each. The sheer scale of this construction is a testament to the ingenuity and determination of the ancient Egyptians. What makes this weight even more impressive is that the pyramid was built over 4,500 years ago, long before the advent of modern construction equipment. The ancient builders used a combination of skilled labor, simple tools, and sophisticated engineering techniques to transport and stack these massive stones with remarkable precision. The weight of the Great Pyramid is not just a matter of physical mass. It also carries the weight of history, engineering, prowess, and human achievement. It stands as a monumental reminder of what our ancestors were capable of accomplishing with limited technology but boundless ambition. The ancient Egyptians used limestone as the primary building material for the pyramids. This sedimentary rock was abundant in the region and relatively easy to quarry. The outer casing of the pyramids was often made from finer, white limestone that was carefully cut and polished to create a smooth surface. Granite, a much harder and more durable stone, was used for specific parts of the pyramid structure. It was typically employed for the lower courses, entrance passages, and interior chambers, providing extra strength and stability to these crucial areas. The ancient builders also incorporated other materials into the pyramid construction. They used mud bricks, made from Nile mud and straw, to build temporary ramps for transporting stone blocks up the sides of the pyramid during construction. Mortar, a mixture of lime, sand, and water, was used sparingly to fill gaps between stone blocks and create a level surface for subsequent layers. Wood played a role in the construction process as well. Cedar and other hardwoods were used to create rollers and sleds for moving heavy stone blocks, as well as for levers and other tools essential to the building process. The precise methods used to lift and place the massive stone blocks remain a subject of ongoing research and debate among archaeologists and engineers. The construction of the Great Pyramid of Giza was a monumental undertaking that spanned several decades. Most Egyptologists estimate that it took approximately 20 to 30 years to complete this colossal structure. The pyramid was built during the reign of Pharaoh Khufu, also known as Cheops, who ruled in the 4th dynasty of ancient Egypt, around 2,560 years before the Common Era. The process involved quarrying and transporting massive limestone blocks, each weighing an average of 2.5 tons, from nearby quarries and from as far away as Aswan, over 800 kilometers to the south. These blocks were then precisely cut and fitted together to form the pyramid's iconic shape. The construction required an immense workforce, with some estimates suggesting that up to 100,000 skilled workers and laborers were involved in the project. The Great Pyramid originally stood at a height of 146 meters, making it the tallest man-made structure in the world for over 3,800 years. Its construction was a testament to the advanced engineering and organizational skills of the ancient Egyptians, who were able to create such a precise and enduring monument without the benefit of modern technology. The time and effort invested in building the Great Pyramid reflect its immense cultural and religious significance to the ancient Egyptians. It served as a tomb for Pharaoh Khufu and was designed to protect his body and possessions for the afterlife, showcasing the deep-rooted beliefs and customs of this remarkable civilization. The Great Pyramids of Giza stand as a testament to human ingenuity and architectural brilliance. These colossal structures, built over 4,500 years ago, continue to captivate our imagination and earn their place among the seven wonders of the ancient world. The sheer scale of the pyramids is awe-inspiring. The largest, known as the Great Pyramid of Khufu, originally stood at a staggering height of 146 meters, making it the tallest human-made structure for nearly 4 millennia. The precision of its construction is remarkable, with the base forming an almost perfect square and the sides aligned to the cardinal points with astonishing accuracy. The engineering feat required to build these monuments is equally impressive. Ancient Egyptians moved and stacked over 2 million stone blocks, each weighing between 2 and 30 tons, without the aid of modern technology. This accomplishment speaks volumes about their advanced knowledge of mathematics, astronomy, and construction techniques. Moreover, the pyramids serve as more than just tombs for pharaohs. They embody the religious and cultural beliefs of ancient Egyptian civilization, representing the pharaoh's journey to the afterlife and his transformation into a god. This blend of architectural marvel and spiritual significance solidifies the Great Pyramid's status as one of the most extraordinary achievements of the ancient world. Ancient Egyptians employed a remarkable array of tools and techniques to construct their awe-inspiring pyramids. Copper chisels and bronze saws were used to cut limestone blocks, while wooden rollers and sleds facilitated the transportation of these massive stones. Ramps played a crucial role in moving blocks up the pyramid as it was being built. These ramps were likely made of mud, brick, and rubble, and their exact design remains a subject of debate among Egyptologists. Some theories suggest straight ramps, while others propose spiral ramps wrapping around the pyramid. For precision work, ancient Egyptian builders utilized plumb bobs, which are weights suspended on strings to ensure accurate vertical alignment. They also employed sophisticated surveying and leveling tools to achieve the pyramid's remarkable accuracy. One such tool was the merket, a sighting tool used in conjunction with a plumb bob for astronomical observations and aligning edges. Hammers and dolerite pounders were used for shaping and smoothing limestone blocks. The ancient Egyptians also created gypsum mortar to fill gaps between stones, ensuring a tight fit. These tools, combined with their advanced knowledge of mathematics, astronomy, and engineering, enabled the creation of structures that continue to captivate our imagination millennia later. Ancient civilizations developed ingenious methods to transport enormous stone blocks for their monumental constructions. One common technique involved the use of wooden rollers or sleds. Workers would place these cylindrical logs beneath the stone, allowing it to be rolled or dragged across the landscape with less friction. Teams of laborers would then pull the massive blocks using ropes made from plant fibers or animal hide. In some cases, ancient engineers created sophisticated pulley systems to move the stones. These systems used a network of ropes and levers to distribute the weight, making it possible for smaller groups of workers to maneuver incredibly heavy loads. For water transportation, large rafts or barges were constructed to float the stones along rivers and canals, greatly reducing the effort required to move them over long distances. Another method involved the use of ramps, particularly for structures like pyramids. As the building grew taller, temporary ramps were constructed alongside it, allowing workers to drag or roll stones up to higher levels. Some theories suggest that these ramps may have spiraled around the structure as it was built, providing a continuous path to the top. Regardless of the specific method used, the transportation of massive stone blocks was a monumental feat of engineering and human cooperation. It required careful planning, innovative problem-solving, and the coordinated efforts of thousands of workers over extended periods of time. Ancient Egyptian builders employed a variety of ingenious techniques to cut and shape the massive limestone blocks used in their monumental structures. Copper chisels and bronze saws with teeth were primary tools, allowing workers to carve and slice through the relatively soft limestone. These metal tools were regularly sharpened to maintain their cutting edge. For larger blocks, wooden wedges were driven into natural fissures in the stone. Workers would then soak these wedges with water, causing the wood to expand and split the rock along its grain. This method proved particularly effective for extracting sizable pieces from quarries. Once extracted, fine-tuning the shape of blocks involved using harder stone hammers and chisels made of dolerite, a type of igneous rock. Skilled craftsmen would carefully chip away at the limestone, gradually achieving the desired form and smooth finish. Abrasive materials like sand were also used to wear down surfaces and create a polished appearance. Remarkably, the ancient Egyptians achieved impressive precision in their stonework without the aid of modern measuring tools. They relied on simple yet effective devices such as plumb bobs and set squares to ensure accurate alignment and right angles. These methods, honed over centuries, allowed for the construction of enduring monuments that continue to captivate us today. The ancient Egyptians demonstrated remarkable engineering skills in aligning their pyramids with astonishing precision. Their methods combined careful planning, advanced tools, and a deep understanding of astronomy and mathematics. One key technique they employed was the use of a tool called a plumb bob, a weight suspended on a string that always points directly downward due to gravity. By using two plumb bobs and sighting between them, Egyptian builders could create perfectly straight lines over long distances. This allowed them to establish accurate right angles and align the pyramid's edges with the cardinal directions. The Egyptians also utilized their knowledge of the stars for alignment. They likely observed the rotation of circumpolar stars, which appear to circle the celestial North Pole. By tracking these stars' movements, they could determine true north with impressive accuracy. This astronomical method, combined with their surveying techniques, enabled them to orient the pyramid's base precisely. Furthermore, the builders employed a system of precise measurements and grid layouts. They divided their construction sites into squares, ensuring each side of the pyramid's base was equal in length and perfectly straight. This meticulous approach, coupled with their sophisticated understanding of geometry, allowed the ancient Egyptians to create structures that continue to amaze us with their precision thousands of years later. The annual floods of the Nile River were crucial to the construction of the ancient Egyptian pyramids. These predictable inundations, occurring each summer, transformed the landscape and provided ideal conditions for massive building projects. During the flood season, the river swelled and deposited rich silt across the floodplain, creating fertile farmland. This agricultural bounty supported a large population and allowed for a complex social structure, including a workforce available for pyramid construction during the dry months. The floods also facilitated the transportation of heavy building materials. When the Nile was at its highest, specially designed boats could navigate closer to construction sites, carrying massive limestone blocks quarried upstream. This waterborne transport significantly eased the logistical challenges of moving enormous quantities of stone. Furthermore, the floodwaters helped in creating a level foundation for the pyramids. The saturated ground could be more easily excavated and smoothed, ensuring a stable base for these monumental structures. As the waters receded, they left behind a perfect building surface, allowing work to commence on the massive monuments that continue to captivate us today. The construction of the Great Pyramid of Giza was an enormous undertaking that required a massive workforce. While the exact number of workers involved remains a subject of debate among historians and archaeologists, recent evidence suggests a smaller workforce than previously thought. Current estimates indicate that around 20,000 to 30,000 skilled workers were employed in building the Great Pyramid. These workers were not slaves, as once believed, but rather paid laborers who were likely farmers during the annual Nile flood season. They worked in rotating shifts, with different groups focusing on various aspects of the construction. The workforce included stonecutters, haulers, architects, engineers, and support staff who provided food, clothing, and tools. Additionally, there were thousands of auxiliary workers who supported the main construction effort, bringing the total number of people involved to potentially 50,000 or more. Interestingly, the efficiency of the ancient Egyptians in organizing this massive project continues to astonish modern engineers. Their ability to coordinate such a large workforce and complete the pyramid within an estimated 20 to 30 years demonstrates remarkable planning and management skills for a civilization that existed over 4,500 years ago. The workforce that built the ancient Egyptian pyramids was far more complex than popular myths suggest. Contrary to widespread belief, the pyramids were not constructed by slaves, but by a diverse group of skilled workers, craftsmen, and farmers. At the top of this social structure were the architects and project managers, highly educated individuals who planned and oversaw the massive construction efforts. Below them were specialized craftsmen such as stonemasons, carpenters, and metalworkers, who shaped and placed the enormous stone blocks with remarkable precision. The bulk of the workforce consisted of temporary laborers, many of whom were farmers who worked on the pyramids during the annual Nile flood when their fields were submerged. These workers were organized into crews and files, each with specific tasks and responsibilities. They were paid in rations of food, beer, and other goods, and evidence suggests they were well fed and received medical care. Recent archaeological discoveries have revealed that the workers lived in planned cities near the construction sites, complete with bakeries, breweries, and copper workshops. This indicates a well-organized, hierarchical society that valued its workforce and invested considerable resources in their well-being, challenging our traditional understanding of ancient Egyptian labor practices. The ancient Egyptians achieved remarkably flat surfaces for the pyramid bases through a combination of ingenious techniques and meticulous attention to detail. They began by digging the ground to bedrock and creating a smooth, level foundation. This process involved removing loose sand and debris, then filling any gaps or crevices with limestone chips. To ensure a perfectly level surface, Egyptian engineers employed a network of channels filled with water. These channels, forming a grid across the construction site, allowed workers to measure the water level at different points, ensuring consistent height throughout the base. Any areas that were too high were carefully chiseled down, while low spots were built up with precisely cut limestone blocks. The Egyptians also used sophisticated surveying tools, including a tool called a plumb bob, which is essentially a weight suspended on a string. This simple yet effective device helped them establish straight vertical lines and right angles. They combined this with sighting tools and measurements based on the stars to achieve remarkable accuracy in aligning the pyramid's base. Once the foundation was level, the Egyptians laid the first course of blocks with extreme precision. These blocks were cut to fit tightly together, with joints often less than a millimeter wide. The outer casing stones were then polished to a smooth finish, creating a seamless surface that would have appeared almost mirror-like when new. Ancient builders employed ingenious techniques to stack and align the massive stone blocks used in monumental structures. One common method involved creating ramps made of earth or smaller stones. These ramps allowed workers to gradually move heavy blocks up the sides of growing structures. As the building rose higher, the ramps were extended or heightened to reach new levels. For precise alignment, ancient engineers likely used plumb bobs, which are weights suspended on strings. These simple tools helped ensure that edges and corners were perfectly vertical. Wooden levers and rollers also played crucial roles in maneuvering stones into place. By placing round logs beneath blocks, workers could roll them with less effort. Levers, often made from sturdy tree trunks, allowed small teams to lift and adjust the position of enormous stones. Some civilizations used sophisticated surveying techniques to achieve precise alignments. The ancient Egyptians, for example, created nearly perfect right angles and straight lines in their pyramids by using a tool called a merket to align with stars. This astronomical approach ensured remarkable accuracy in construction. Water was another valuable tool in the ancient builders' arsenal. By digging channels and filling them with water, they created level surfaces that guided the placement of foundation stones. This technique, combined with the other methods, allowed for the creation of structures that have endured for millennia, testament to the ingenuity of our ancestors. Ancient Egyptian pyramid builders employed ingenious techniques to maintain the precise shape of these monumental structures as they rose skyward. They began with a perfectly level foundation, meticulously surveyed and prepared to support the immense weight of the pyramid. As construction progressed, workers used a tool called a plumb bob, essentially a weight suspended on a string, to ensure the edges of the pyramid remained straight and aligned. The builders also utilized a stepped core of limestone blocks as the internal structure. Another crucial technique was the use of corner sockets and casing stones at the base of the pyramid. These precisely cut and placed stones established the correct angle and orientation for the entire structure. As construction continued upward, workers constantly checked and adjusted their work against these baseline measurements, ensuring the pyramid maintained its intended shape throughout the building process. The ancient Egyptians' remarkable understanding of geometry and their meticulous attention to detail allowed them to create these awe-inspiring structures that have endured for millennia, standing as a testament to their architectural and engineering prowess. Ancient Egyptians developed a sophisticated understanding of mathematics that was far ahead of many other civilizations of their time. Their knowledge was deeply practical, driven by the needs of agriculture, construction, and commerce. The Egyptian number system was decimal and based on powers of 10, much like our modern system. They had symbols for 1, 10, 100, 1,000, and so on, allowing them to represent large numbers efficiently. This system enabled complex calculations necessary for their monumental building projects. Geometry was a particular strength of Egyptian mathematicians. They could accurately calculate the area of rectangles, triangles, and circles, as well as the volume of cylinders and other shapes. This knowledge was crucial for land surveying, especially after the annual Nile floods, and for designing and constructing the pyramids and other massive structures. The Egyptians also developed a basic understanding of algebra, though not in the formal sense we know today. They could solve linear equations and had methods for dealing with fractions, which they represented as sums of unit fractions. Their mathematical texts, such as the Rhind Papyrus, show they could tackle complex problems involving resource distribution and architectural planning. The ancient Egyptians were masterful architects and mathematicians, and their use of the golden ratio in pyramid design showcases their advanced understanding of geometry. While they may not have explicitly known about the golden ratio as we define it today, they intuitively incorporated its principles into their monumental structures. The golden ratio, approximately 1.618 to 1, appears in the proportions of the Great Pyramid of Giza. When we examine the ratio of the pyramid's slant height to half its base, we find a close approximation to this mathematical constant. This suggests that the ancient Egyptians had a sophisticated grasp of aesthetic proportions that we now associate with the golden ratio. Interestingly, this ratio is not just visually pleasing, but also structurally sound. The angle created by these proportions, about 52 degrees, is ideal for pyramid construction, allowing for stability and durability over millennia. This demonstrates that the Egyptians combined their sense of beauty with practical engineering considerations. The presence of the golden ratio in Egyptian pyramids continues to fascinate scholars and enthusiasts alike. It raises questions about the extent of ancient Egyptian mathematical knowledge and their ability to apply complex geometric principles to architectural design. Their achievements in this realm underscore the sophistication of early civilizations and their enduring impact on our understanding of mathematics and aesthetics. The Great Pyramids of Giza have long fascinated researchers with their potential astronomical alignments. These ancient Egyptian structures, built over 4,000 years ago, demonstrate a remarkable level of precision in their construction and orientation. One of the most notable alignments is the orientation of the pyramid's bases. The sides of the Great Pyramid of Khufu are aligned almost exactly with the four cardinal directions: north, south, east, and west. This alignment is so precise that it deviates from true north by only a fraction of a degree. An impressive feat, considering the tools available at the time of construction. Another intriguing feature is the alignment of the descending passage in the Great Pyramid. This narrow corridor points towards the north celestial pole, which at the time of the pyramid's construction would have been aligned with the star Thuban in the constellation Draco. This alignment has led some researchers to speculate that the pyramid may have been used as an astronomical observatory. The positioning of the three main pyramids at Giza has also been subject to much study. Some researchers have suggested that their arrangement mirrors the pattern of the three stars in Orion's belt. While this theory remains controversial among Egyptologists, it highlights the ongoing interest in potential astronomical connections within these ancient structures. The ancient Egyptians achieved a remarkable feat of engineering and astronomical precision when constructing the Great Pyramids of Giza. These massive structures are aligned to true north with astonishing accuracy. The base of the Great Pyramid of Khufu is aligned to the cardinal directions within just a fraction of a degree. Modern surveys have revealed that the east-west axis of the Great Pyramid is offset from true north by only 3 arc minutes, or about 1/20th of a degree. This level of precision is truly impressive, considering the pyramid was built over 4,500 years ago without the benefit of modern surveying tools or knowledge of the Earth's magnetic field. To put this accuracy into perspective, if you were to draw a line from the center of the pyramid's base to the North Pole, it would only deviate from true north by about the width of a human hair, over a distance of about 1 mile. This extraordinary alignment has long fascinated archaeologists, engineers, and astronomers, sparking debates about the methods and knowledge the ancient Egyptians possessed. Various theories have been proposed to explain how the Egyptians achieved this feat, including the use of stellar observations, shadow casting techniques, and even the possibility of a now-lost understanding of the Earth's rotation. Regardless of the method, the precision of the pyramid's alignment stands as a testament to the ingenuity and skill of ancient Egyptian builders and astronomers. The ancient Egyptians employed remarkably advanced surveying methods to construct their monumental pyramids with astonishing precision. One key technique they used was the plumb bob, a weight suspended on a string to establish a true vertical line. This simple yet effective tool allowed builders to ensure the pyramid's edges were perfectly straight and aligned. Another crucial method was the use of sophisticated leveling techniques. Egyptians created a network of channels filled with water around the base of the pyramid. By observing the water level at different points, they could achieve an incredibly flat foundation, essential for the stability and symmetry of the massive structure. The ancient builders also utilized astronomical observations to align the pyramids with incredible accuracy. They used the positions of certain stars, particularly those in the constellation Orion, to orient the pyramid's sides precisely to the cardinal directions. This astronomical surveying demonstrated their deep understanding of celestial movements and their ability to translate this knowledge into practical construction techniques. Furthermore, the Egyptians developed a standardized unit of measurement called the cubit, based on the length of a forearm. This allowed for consistent and precise measurements across the entire construction site, ensuring that blocks cut in different locations would fit together seamlessly when assembled. The ancient Egyptians achieved remarkable precision in constructing the right angles of their pyramids through a combination of advanced mathematical knowledge and ingenious tools. They employed a device called a plumb bob, which is essentially a weight suspended on a string. This simple yet effective tool allowed them to establish perfectly vertical lines. To create right angles, the Egyptians used a technique involving a rope knotted to form a triangle with sides in the ratio of 3:4:5. This method, later formalized as the Pythagorean theorem, ensured that the angle between the shorter sides was exactly 90 degrees. By using this rope triangle in conjunction with the plumb bob, they could accurately lay out the square base of the pyramid. The Egyptians also developed sophisticated surveying techniques to ensure the ground was perfectly level before construction began. They created a network of channels filled with water around the perimeter of the building site. The water surface provided a reference plane, allowing them to achieve a flat foundation accurate to within mere centimeters across the entire base. These methods, combined with their extensive experience in construction and a meticulous attention to detail, enabled the ancient Egyptians to create structures with astonishing geometric precision. Their techniques were so effective that modern surveys of the Great Pyramid of Giza have found its base to be almost perfectly square, with sides differing in length by less than 0.1%. The ancient Egyptians demonstrated a remarkable understanding of mathematical concepts, including an approximation of pi long before it was formally defined. Evidence of their grasp of this fundamental constant comes from several sources, most notably the Rhind mathematical papyrus. This document, dating back to around 1650 BCE, contains mathematical problems and their solutions. One problem in the papyrus describes how to calculate the area of a circular field. The solution involves squaring 8/9 of the diameter, which results in a value for pi of about 3.16. While not exact, this approximation is impressively close to the true value of pi and suggests a sophisticated level of mathematical understanding. Further evidence comes from the construction of the pyramids themselves. The Great Pyramid of Giza, built around 2500 BCE, exhibits proportions that closely align with pi. The ratio of the pyramid's perimeter to its height is remarkably close to 2 pi, indicating that the ancient Egyptians may have intentionally incorporated this mathematical constant into their architectural designs. These findings suggest that the ancient Egyptians had a practical, if not theoretical, understanding of pi. Their ability to apply this knowledge in both calculations and monumental construction projects speaks to the advanced state of Egyptian mathematics and engineering thousands of years ago. Ancient builders employed several ingenious techniques to maintain symmetry during construction. One common method was the use of a plumb bob, a weight suspended on a string that always points directly downward due to gravity. This simple tool allowed builders to ensure vertical alignment and symmetry in their structures. Another crucial technique was the creation of precise foundation layouts. Builders would carefully measure and mark the ground, often using knotted ropes or cords to create accurate right angles and equal distances. This initial groundwork served as a blueprint for the entire structure, ensuring symmetry from the ground up. For circular structures, builders often used a technique similar to a giant compass. They would drive a stake into the center of the planned building and attach a rope. By keeping the rope taut and moving it around the center point, they could mark out a perfect circle, maintaining symmetry in all directions. In some cases, builders created scale models or detailed drawings before beginning construction. These served as guides throughout the building process, allowing workers to continually check their progress against the planned design and make adjustments as needed to maintain symmetry. The ancient Egyptians demonstrated remarkable geological knowledge in constructing the pyramids, particularly the Great Pyramid of Giza. They selected limestone from local quarries, choosing blocks with specific properties that made them ideal for construction. This limestone was softer when first quarried, allowing for easier cutting and shaping, but hardened over time when exposed to air, creating a more durable structure. The builders also incorporated granite, a much harder stone, for specific structural elements like support beams and internal chambers. This material was quarried from Aswan, over 500 miles away, showcasing their understanding of different rock types and their properties. The precision with which these massive stone blocks were cut and fitted together, often with gaps less than a millimeter wide, indicates an advanced understanding of stone's physical properties. Furthermore, the ancient Egyptians used gypsum mortar between the limestone blocks, which not only acted as a lubricant during construction but also filled in gaps and hardened over time, adding to the pyramid's structural integrity. This knowledge of how different materials interact and change over time demonstrates a sophisticated grasp of geological processes. The orientation and construction of the pyramids also suggest an understanding of the local geology. The builders created remarkably level foundations on the Giza Plateau, compensating for natural variations in the bedrock. This feat required not only engineering skill, but also an intimate knowledge of the underlying geological formations and how to work with them effectively. The ancient Egyptians employed remarkable engineering techniques to create the smooth outer casing of the pyramids. They began by constructing the core of the pyramid using roughly cut limestone blocks. Once the core was complete, they added a layer of finely cut white limestone blocks, known as casing stones. These casing stones were quarried from nearby limestone deposits and transported to the construction site. The stones were cut with incredible precision, often to within fractions of an inch, to ensure a tight fit. The Egyptians used copper chisels, bronze saws, wooden rollers and sleds, ramps and levers to cut and transport these massive stones. To achieve the smooth, polished surface, the builders worked from the top down. They fitted the casing stones tightly together, then used abrasive materials like sandstone blocks to grind the outer surface to a flat, smooth finish. This grinding process was incredibly time-consuming but resulted in a seamless, gleaming surface that reflected the sun's rays. The precision of their work was so exceptional that even today, the few remaining casing stones fit together so tightly that it is impossible to slide a knife blade between them. This outer casing not only created a visually stunning monument, but also protected the inner core of the pyramid from weathering, helping these ancient wonders endure for millennia. The shafts discovered within the Great Pyramid of Giza have long puzzled archaeologists and historians. These narrow passages, often referred to as air shafts, extend from the king's chamber and queen's chamber, pointing towards specific celestial bodies in the ancient Egyptian sky. One prevailing theory suggests that these shafts served a spiritual purpose, acting as pathways for the pharaoh's soul to ascend to the heavens after death. The northern shaft from the king's chamber aligns with the circumpolar stars, which the ancient Egyptians associated with eternal life. The southern shaft points towards the constellation Orion, linked to the god Osiris in Egyptian mythology. However, some researchers propose that these shafts might have had practical functions as well. They could have been used for ventilation during construction or to lower stones into place. Others speculate that they might have played a role in astronomical observations or as part of a complex alignment system within the pyramid. Despite extensive study, the true purpose of these shafts remains a subject of debate. Their precise alignment and careful construction suggest they held great significance to the ancient Egyptians, blending their advanced architectural skills with their deep spiritual beliefs and astronomical knowledge. The construction of the Great Pyramid of Giza, particularly the King's Chamber, remains a marvel of ancient engineering. The massive granite blocks used in the King's Chamber were quarried from Aswan, located over 500 miles south of Giza. These enormous stones, some weighing up to 70 tons, were transported along the Nile River using large wooden boats during the annual flood season when water levels were high. Once at Giza, the ancient Egyptians employed a combination of ingenious techniques to move and place these colossal blocks. They likely used sleds, ramps, and levers to maneuver the stones into position. Copper chisels and bronze saws with teeth made of hard stones were used to shape the granite blocks precisely. The ancient builders also utilized a system of counterweights and pulleys to lift the massive stones. The placement of these blocks required extraordinary precision. The ancient Egyptians used plumb bobs, set squares, and leveling instruments to ensure accurate alignment. They also employed a technique called corbelling, where each successive layer of stones was placed slightly inward, creating a self-supporting structure that could bear the immense weight above. The level of craftsmanship in the King's Chamber is astounding, with joints between the granite blocks so tight that even a credit card cannot be inserted between them. This precision, achieved over 4,000 years ago, continues to baffle and impress modern engineers and archaeologists, showcasing the remarkable skills and knowledge of the ancient Egyptian builders. The Great Pyramid of Giza continues to astound and puzzle researchers with its intricate design, including the enigmatic features known as the air shafts. These narrow, straight passages extend from the king's and queen's chambers, pointing towards specific celestial bodies in the ancient Egyptian sky. Contrary to their name, these shafts likely served no ventilation purpose. Instead, many Egyptologists believe they held profound religious and astronomical significance. The northern shaft from the king's chamber aligns with the circumpolar stars, which the ancient Egyptians associated with eternal life. The southern shaft points towards Orion's belt, linked to the god Osiris in Egyptian mythology. The shafts from the queen's chamber present an even greater mystery. The northern shaft appears to target the circumpolar stars, while the southern one aligns with Sirius, the brightest star in the night sky. Sirius was deeply connected to the goddess Isis and played a crucial role in the Egyptian calendar. Some researchers propose these shafts acted as conduits for the pharaoh's soul to ascend to the heavens, joining the gods in the afterlife. Others suggest they might have been used for celestial observations or to mark important astronomical events. Regardless of their exact purpose, these precision-engineered passages demonstrate the ancient Egyptians' remarkable architectural skill and their deep connection to the cosmos, adding another layer of wonder to the already awe-inspiring Great Pyramid. The absence of hieroglyphics and decorations inside the Great Pyramid of Giza has long puzzled archaeologists and historians. Unlike many other ancient Egyptian tombs and monuments, the interior of this colossal structure is strikingly bare. This peculiarity sets it apart from later pyramids and has led to numerous theories about its purpose and construction. One prevailing explanation is that the Great Pyramid, built for Pharaoh Khufu around 2550 BCE, represents an earlier stage in the evolution of Egyptian funerary practices. At this time, the emphasis may have been more on the structure itself as a means to ensure the pharaoh's immortality rather than on elaborate decorations. Another theory suggests that the lack of decorations might be due to the pyramid's unique construction process. The Great Pyramid was built from the inside out, with blocks being added in layers. This method may have made it impractical or impossible to add intricate decorations to the interior walls. Additionally, the smooth limestone casing that once covered the exterior of the pyramid may have been considered sufficient decoration in itself. Some researchers propose that there may have been decorations that were later removed or that have deteriorated over time. However, the lack of any trace of pigments or chisel marks makes this theory less likely. Ultimately, the barren interior of the Great Pyramid remains one of its most intriguing mysteries, continuing to fuel speculation and research into the methods and motivations of its ancient builders. The subterranean chamber beneath the Great Pyramid of Giza remains a subject of fascination and debate among archaeologists and historians. Located about 100 feet below ground level, this mysterious room was carved directly into the bedrock beneath the pyramid. Its exact purpose has puzzled researchers for centuries. One prevailing theory suggests that the chamber was initially intended to be the main burial chamber for the pharaoh Khufu, for whom the Great Pyramid was built. However, this plan may have been abandoned during construction, possibly due to engineering challenges or changes in religious beliefs. The unfinished state of the chamber, with its rough-hewn walls and floor, supports this hypothesis. Another intriguing possibility is that the subterranean chamber served a symbolic or ritualistic function. Some scholars propose that it might represent the underworld in ancient Egyptian cosmology, playing a crucial role in the pharaoh's journey to the afterlife. The chamber's depth and darkness could symbolize the depths of the earth and the realm of the dead. Some researchers have also speculated about more practical purposes for the chamber. It might have been used for storage, perhaps housing items needed for the pharaoh's afterlife. Alternatively, it could have played a role in the construction process, possibly as a guide for aligning the pyramid or as a water reservoir for the workers. While these theories are compelling, the true purpose of this enigmatic underground room continues to elude us, adding to the enduring mystery of the Great Pyramid. The ancient Egyptians achieved remarkable precision in creating the flat surface of the pyramid plateau through a combination of advanced engineering techniques and meticulous craftsmanship. They began by carefully surveying the limestone bedrock, identifying and removing any irregularities or protrusions. Using copper chisels and bronze saws with jewel-tipped teeth, they painstakingly smoothed the surface, constantly checking their progress with water-filled trenches that acted as primitive levels. To ensure an even foundation, the Egyptians employed a technique called true leveling. They cut a network of channels into the bedrock and filled them with water. By marking the water level on the channel walls and then removing the excess rock, they created a perfectly flat surface across the entire plateau. This method allowed them to achieve an astonishing degree of accuracy, with height differences of less than half an inch across the entire 13-acre base of the Great Pyramid. The Egyptians further refined the surface by filling any remaining depressions with limestone blocks, carefully fitted and leveled to match the surrounding bedrock. They then added a layer of fine white limestone casing stones, meticulously smoothed and polished, to create a seamless, mirror-like finish. This attention to detail and precision laid the groundwork for the construction of the pyramids themselves, ensuring their stability and longevity for millennia to come. The relieving chambers above the king's chamber in the Great Pyramid of Giza serve a crucial structural purpose. These 5 hollow spaces, stacked one above the other, distribute the immense weight of the pyramid's upper masonry, preventing it from crushing the ceiling of the king's chamber below. Each chamber is formed by massive granite beams, with the lowest chamber featuring a distinctive peaked roof. This design cleverly transfers the load from the center of the chamber to its sides, effectively protecting the flat ceiling of the king's chamber from the enormous pressure above. Interestingly, these chambers also provide valuable insights into the pyramid's construction. The walls of these spaces bear marks and inscriptions left by ancient work crews, offering glimpses into the building process and the organization of labor during the pyramid's creation. Beyond their practical function, the relieving chambers have sparked curiosity among researchers and enthusiasts alike, leading to various theories about their potential symbolic or astronomical significance within the overall design of this ancient wonder. The ancient Egyptians chose granite for the king's chamber in the Great Pyramid of Giza for several important reasons. Granite is a much harder and more durable stone than limestone, making it ideal for protecting the pharaoh's burial chamber. This robust material could withstand the immense weight of the pyramid above it and resist potential tomb robbers. Granite also held great symbolic significance for the Egyptians. They associated its red color with the sun and rebirth, crucial concepts in their beliefs about the afterlife. The use of this prestigious stone in the most sacred part of the pyramid emphasized the pharaoh's divine status and importance. Limestone, on the other hand, was abundant near the building site and easier to quarry and shape. It served well for the bulk of the pyramid's construction, providing a stable and relatively lightweight structure. The Egyptians skillfully combined these materials, using each for its specific properties and meanings. This strategic use of different stones showcases the ancient Egyptians' advanced understanding of materials and engineering. They created a monument that has endured for millennia, with the Granite King's Chamber remaining one of the best preserved parts of the Great Pyramid to this day. The so-called door inside the Great Pyramid of Giza has long intrigued archaeologists and historians. Located at the end of a narrow shaft leading from the Queen's Chamber, this stone slab with copper fittings has sparked numerous theories about its purpose and what might lie beyond it. Recent explorations using small robots have revealed that this structure is not actually a door but rather a blocking stone. The copper fittings, once thought to be handles, are now believed to be ceremonial or decorative elements. Behind this blocking stone, researchers have discovered another chamber, though its contents and purpose remain unknown. Some experts suggest that these shafts and chambers might have served as pathways for the pharaoh's spirit to ascend to the afterlife. Others propose they could have been used for ventilation during construction or had some astronomical significance. The true purpose of these features, including the blocking stone, continues to be a subject of debate among Egyptologists. The mystery surrounding this door and the hidden chambers of the Great Pyramid underscores how much we still have to learn about ancient Egyptian construction techniques and beliefs. As technology advances, we may yet uncover more secrets concealed within this monumental structure, shedding light on the enigmatic practices of one of the world's most fascinating civilizations. The ancient Egyptians demonstrated remarkable skill in their stonework, achieving incredibly precise joinery between massive stone blocks that continues to astound us today. Their techniques were a combination of ingenuity, patience, and meticulous craftsmanship. One key method they employed was the use of copper chisels and bronze saws with abrasive sand. These tools allowed them to cut and shape limestone and granite with surprising accuracy. The workers would first roughly cut the blocks to size, then use a technique called truing to create perfectly flat surfaces. This involved rubbing the faces of the blocks against each other with a layer of sand between them, gradually wearing down any irregularities. For the tightest fits, especially in important structures like temples and tombs, the Egyptians used a method called optical surveying. They would flood the joint between two blocks with water and observe where light reflected off the water's surface. This allowed them to identify and smooth out even the tiniest imperfections, resulting in the incredibly tight seams we see today. The ancient Egyptians also employed sophisticated leveling techniques to ensure blocks were perfectly aligned. They used plumb bobs and set level lines across the construction site, allowing them to maintain precision over large distances. This attention to detail, combined with their advanced stoneworking methods, enabled them to create structures with joints so tight that even today, it is often impossible to insert a knife blade between the massive stone blocks. While the ancient Egyptians' methods for building the pyramids are well documented, several alternative theories have captured public imagination. One popular idea suggests that the pyramids were constructed using a form of ancient concrete rather than carved limestone blocks. Proponents argue that this would explain the precise fit between stones and simplify the transportation process. Another theory proposes that the ancient Egyptians used advanced levitation techniques, possibly involving sound waves or other unknown technologies, to move and position the massive stone blocks. This idea often goes hand in hand with claims of extraterrestrial involvement or lost advanced civilizations. Some researchers have suggested that the pyramids were built from the top down, using sophisticated scaffolding systems and counterweights. This theory challenges the traditional bottom-up construction model, but has not gained widespread acceptance among archaeologists. A more recent hypothesis proposes that the ancient Egyptians used water to their advantage, creating a series of locks and canals to float stone blocks closer to the construction site. While this idea addresses some logistical challenges, it lacks substantial evidence in the archaeological record. The internal ramp theory offers a compelling explanation for how ancient Egyptians might have constructed the massive pyramids. This theory proposes that instead of using an external ramp to transport heavy stone blocks, the builders incorporated a spiral ramp inside the pyramid itself. As the pyramid grew taller, the internal ramp would have wound its way up through the structure, allowing workers to continually move stone blocks to higher levels. This spiral pathway would have been filled in with blocks as construction progressed, eventually becoming part of the finished pyramid. One key advantage of this method is that it would have allowed for a much steeper slope than an external ramp, making it more efficient and requiring less material. The theory also suggests that the corners of the pyramid were built first, with the internal ramp snaking between them. This approach would have made it easier to maintain the precise geometry of the pyramid as it rose. Proponents of the internal ramp theory point to evidence such as anomalies detected in the internal structure of some pyramids, which could indicate the presence of these hidden ramps. While not universally accepted, this theory provides a plausible solution to the long-standing mystery of pyramid construction techniques. The concrete theory of pyramid construction proposes an innovative approach to how the ancient Egyptians might have built their monumental structures. This theory suggests that instead of quarrying, transporting, and precisely fitting enormous limestone blocks, the Egyptians could have used a form of ancient concrete to cast the blocks in place. According to this hypothesis, workers would have quarried and transported smaller amounts of limestone, which they then crushed and dissolved in large pools of water. The resulting slurry would be mixed with lime, natron, and other locally sourced minerals to create a type of concrete. This mixture could then be poured into wooden molds directly on the construction site, forming blocks as they dried. Proponents of this theory argue that it could explain how the pyramids were built with such precision and in a relatively short time frame. They point to microscopic analysis of pyramid limestone samples, which they claim show characteristics more consistent with concrete than with natural, quarried limestone. However, this theory remains highly controversial among Egyptologists and archaeologists. Many experts argue that there is substantial evidence for traditional quarrying and transportation methods, and that the limestone used in the pyramids is consistent with known ancient quarry sites. The debate continues, highlighting the enduring mystery and fascination surrounding the construction of these ancient wonders. The water shaft theory offers an intriguing alternative explanation for the construction of the ancient Egyptian pyramids. This hypothesis suggests that the ancient builders used the power of water to their advantage, creating a system of waterways and locks to transport massive stone blocks. According to this theory, the Egyptians would have dug a series of shafts and tunnels around the pyramid site, filling them with water from the nearby Nile River. These water-filled passages would have formed a network of canals, allowing large limestone blocks to be floated on wooden rafts or boats to their intended locations. As the pyramid grew taller, the water level in these shafts would have been gradually raised, enabling the continued transport of stones to higher levels. Proponents of this theory argue that it would have significantly reduced the manpower required to move the enormous blocks, making the construction process more efficient and less labor-intensive. While the water shaft theory presents an innovative approach to pyramid construction, it remains controversial among Egyptologists and archaeologists. Critics point out the lack of archaeological evidence for such an extensive water transport system and question the practicality of maintaining water levels in the desert environment. Despite these challenges, the theory continues to spark debate and inspire further research into the remarkable engineering feats of ancient civilizations. The idea of lost advanced technology from ancient civilizations is an intriguing concept, but it's important to note that there is no solid scientific evidence supporting this theory. Archaeological and historical research consistently shows that human technological progress has been gradual and cumulative over time. Many claims about lost advanced technology stem from misinterpretations of ancient artifacts or structures. For example, the precise construction of the Egyptian pyramids or the sophisticated astronomy of the Maya are often cited as evidence of advanced technology. However, careful study reveals that these achievements were the result of impressive but explicable ancient engineering and observational skills. Researchers have demonstrated how ancient people could have built monumental structures using tools and techniques appropriate to their time. Similarly, ancient astronomical knowledge was developed through centuries of careful observation and record-keeping, not through advanced technology as we understand it today. While our ancestors were certainly ingenious and capable of remarkable feats, the archaeological record shows a clear progression of technological development. The evidence we have points to human innovation and problem-solving rather than the existence and subsequent loss of highly advanced technology. The acoustic levitation theory proposes an intriguing explanation for how ancient civilizations might have moved enormous stones to build monumental structures. This concept suggests that sound waves, when precisely controlled and amplified, could potentially create a lifting force strong enough to counteract gravity and move heavy objects. According to this theory, ancient builders might have used a combination of sound-generating devices and carefully designed acoustic chambers to create powerful standing waves. These waves could theoretically create areas of high and low pressure in the air, forming a kind of invisible cushion that could lift and move massive stones with minimal physical effort. Proponents of this idea point to certain ancient texts and folklore that mention the use of sound or music in construction. They also draw parallels with modern acoustic levitation experiments where small objects can be suspended in air using high-frequency sound waves. However, it is important to note that scaling this effect up to the size needed for megalithic construction presents significant challenges. While the acoustic levitation theory is fascinating, it remains highly speculative and lacks solid scientific evidence to support its application in ancient construction. Most archaeologists and engineers favor more conventional explanations involving ramps, levers, and other mechanical methods for moving large stones. Nevertheless, the theory continues to captivate the imagination and inspire further research into the potential applications of acoustic technology. The ancient aliens theory proposes that extraterrestrial beings visited Earth in the distant past and assisted ancient civilizations in constructing monumental structures like the pyramids. Proponents of this idea argue that the precision and scale of these structures were beyond the technological capabilities of ancient humans. This theory suggests that aliens provided advanced knowledge, tools, or even direct intervention to help build the pyramids. Supporters often point to the massive size of the stone blocks used, the precise alignment of the structures, and their purported astronomical significance as evidence of otherworldly involvement. However, mainstream archaeologists and historians reject these claims. They have extensively documented the gradual development of ancient Egyptian engineering and construction techniques. Archaeological evidence shows that the Egyptians used sophisticated but entirely human methods to quarry, transport, and stack the massive stone blocks. While the ancient aliens theory captures the imagination, it disregards the ingenuity and capabilities of our ancestors. The pyramids stand as a testament to human innovation, organization, and determination rather than evidence of extraterrestrial intervention. The theory of advanced ancient civilizations proposes that highly sophisticated societies existed in the distant past, possessing knowledge and technology far beyond what is traditionally attributed to their era. This controversial idea suggests that these civilizations had access to advanced methods for constructing massive structures like pyramids. Proponents of this theory argue that the precise engineering and astronomical alignments found in many ancient pyramids indicate a level of scientific understanding that surpasses conventional historical timelines. They point to the incredible precision in the construction of the Great Pyramid of Giza, with its nearly perfect alignment to true north and its intricate internal chamber system, as evidence of advanced knowledge. Some supporters of this theory speculate that these ancient builders might have used levitation techniques or anti-gravity devices to move and place the massive stone blocks. Others suggest the use of advanced cutting tools, possibly powered by electricity or other energy sources not typically associated with ancient times. These hypothetical technologies would explain how enormous stones were transported and fitted together with remarkable accuracy. However, it is important to note that mainstream archaeologists and historians generally reject these theories. They argue that conventional explanations, involving ramps, levers, and a large workforce, adequately account for pyramid construction techniques. The debate continues, with researchers on both sides seeking evidence to support their views on how these ancient wonders were built. Some theorists propose an intriguing idea about the role of sound in ancient Egyptian pyramid construction. They suggest that acoustic levitation might have been used to move and position the massive stone blocks. This theory posits that the ancient Egyptians could have utilized specific sound frequencies to create standing waves, which would generate areas of reduced gravity. The concept revolves around the idea that certain sound frequencies can create a type of acoustic field that counteracts the effects of gravity on objects within that field. Proponents of this theory argue that by using carefully tuned instruments and a deep understanding of acoustics, the pyramid builders might have been able to lift and maneuver enormous stones with relative ease. While this theory captures the imagination, it's important to note that it remains highly speculative and lacks substantial scientific evidence. Mainstream archaeologists and physicists generally do not support this idea, as the energy required to levitate such massive objects using sound would be enormous and impractical with ancient technology. Nevertheless, the exploration of such theories highlights the ongoing fascination with the construction methods of the ancient Egyptians and the enduring mystery surrounding the building of the pyramids. It also underscores the human desire to find extraordinary explanations for remarkable achievements of the past. Ancient Egyptian architects demonstrated remarkable precision in aligning the pyramids with celestial bodies. Some alternative theories propose that this accuracy stems from advanced astronomical knowledge, possibly inherited from an earlier, unknown civilization. These ideas suggest the builders possessed sophisticated methods for tracking stars and understanding celestial mechanics. One theory posits that the alignment of the Great Pyramid of Giza, with true north, accurate to within a fraction of a degree, indicates a deep understanding of Earth's rotation and the movement of stars. Proponents argue this level of precision would be difficult to achieve without advanced instruments or mathematical concepts not officially attributed to ancient Egyptians. Another explanation suggests the pyramids were designed as star maps, mirroring specific constellations. This theory claims the layout of the Giza Plateau corresponds to the pattern of stars in Orion's belt. Supporters argue this alignment served a spiritual purpose, connecting the pharaoh's tombs with the gods in the night sky. While these alternative theories are intriguing, most archaeologists and Egyptologists maintain that the ancient Egyptians achieved their impressive alignments through careful observation and basic tools. They likely used the movements of the sun and stars, combined with simple surveying techniques, to orient their massive structures with remarkable accuracy. Archaeological discoveries have revealed intriguing artifacts that challenge our understanding of ancient technological capabilities. The Baghdad Battery, discovered in Iraq and dating back to the Parthian period, consists of a ceramic pot, copper cylinder, and iron rod. Some researchers suggest it could have been used to generate an electric current, though its exact purpose remains debated. In Egypt, the precision and complexity of structures like the Great Pyramid of Giza continue to astound modern engineers. The massive stone blocks, some weighing up to 70 tons, were cut and transported with remarkable accuracy, fitting together with gaps of less than a millimeter. This level of precision suggests sophisticated engineering knowledge and tools that seem beyond the perceived capabilities of ancient civilizations. Ancient Indian texts describe flying machines called vimanas, with detailed explanations of their construction and operation. While these accounts are often dismissed as mythology, they raise questions about the possible existence of advanced aeronautical knowledge in ancient times. Similarly, the Antikythera mechanism, an ancient Greek analog computer used to predict astronomical positions, demonstrates a level of mechanical complexity previously thought impossible for its time. These examples, among others, have led some researchers to propose that ancient civilizations may have possessed technologies far more advanced than traditionally believed. However, mainstream archaeology remains cautious, emphasizing the need for further evidence and rigorous scientific analysis to support such claims. Ancient Egyptian pyramid construction has long fascinated scholars and the public alike, with many wondering how these massive structures were built with such precision thousands of years ago. Some theorists suggest that lost technologies might explain the remarkable accuracy and engineering feats displayed in pyramid construction. One intriguing idea proposes that ancient Egyptians possessed advanced tools and techniques that have since been forgotten or lost to time. These could include sophisticated surveying instruments for achieving precise alignments and measurements, or specialized cutting tools capable of shaping and fitting massive stone blocks with incredible accuracy. Another theory suggests the use of now unknown construction methods, such as techniques for moving and lifting enormous stone blocks that surpass our current understanding of ancient capabilities. Some speculate about the existence of machines or devices that could manipulate gravity or leverage principles of physics in ways we have yet to rediscover. However, it is important to note that many Egyptologists and archaeologists argue that conventional tools and techniques, combined with the Egyptians' remarkable engineering skills and meticulous planning, can adequately explain pyramid construction. The debate continues, spurring ongoing research and exploration into the methods used by these ancient master builders. Ancient texts and legends from various cultures contain intriguing references that some interpret as hints of advanced technologies in antiquity. The Indian epic Mahabharata describes flying machines called vimanas, capable of incredible feats like interplanetary travel. These accounts include detailed descriptions of their construction and operation, sparking debate about their true nature. In ancient Sumerian texts, stories of the Anunnaki mention advanced beings descending from the sky, bringing knowledge and technology to early humans. Some researchers speculate these tales might be linked to extraterrestrial visitations or forgotten human achievements. The Bible contains passages that some believe allude to advanced technology. Ezekiel's vision of a wheeled flying object with gleaming metal has been interpreted by some as a description of an alien spacecraft. Similarly, the destruction of Sodom and Gomorrah has been speculated to describe a nuclear explosion. Greek mythology also offers tantalizing hints. The story of Daedalus and Icarus, with their human-made wings, might be seen as an early attempt at aviation. The legendary island of Atlantis, described by Plato, is often imagined as an advanced civilization with technology beyond its time. Some researchers propose an intriguing theory that ancient Egyptians might have harnessed electricity in ways we're only beginning to understand. They point to certain artifacts and depictions in Egyptian tombs as potential evidence for this claim. One such artifact is the so-called Dendera light, a relief carving in the Hathor temple that some interpret as depicting a large light bulb. These researchers suggest that the ancient Egyptians might have used a form of battery to generate electricity. They speculate that jars filled with acidic liquid, copper, and iron could have functioned as primitive galvanic cells. This setup, they argue, could have produced a small electrical current. Another piece of evidence cited is the lack of soot on the ceilings of some Egyptian tombs. Traditional lighting methods like torches or oil lamps would have left residue, leading some to speculate that the ancient Egyptians used electric lighting. However, it's important to note that mainstream archaeologists and historians largely reject these theories. Most experts attribute the advanced achievements of ancient Egyptians to their sophisticated understanding of engineering, mathematics, and astronomy rather than electricity. They argue that the evidence for ancient Egyptian electrical technology is based on misinterpretations of artifacts and inscriptions. Nonetheless, this theory continues to captivate the imagination of some researchers and enthusiasts, sparking ongoing debate about the extent of ancient technological knowledge. Magnetism likely played a subtle yet significant role in ancient construction techniques, particularly in the realm of navigation and alignment. Ancient builders, especially those working on monumental structures, often needed precise directional information to orient their creations. The Earth's magnetic field provided a consistent reference point that could be harnessed using simple tools. One of the most intriguing applications of magnetism in ancient construction was the use of lodestones. These naturally magnetized pieces of magnetite were used to create early compasses. By floating a lodestone on water or suspending it on a string, ancient builders could determine magnetic north with remarkable accuracy. This knowledge was crucial for aligning structures with cardinal directions or specific celestial events. In some cultures, magnetic alignment was believed to have spiritual or cosmological significance. Certain temples and tombs were positioned to align with magnetic north, possibly reflecting a belief in the connection between earthly and celestial forces. While not all ancient structures show evidence of magnetic alignment, those that do suggest a sophisticated understanding of natural phenomena and their practical applications in construction. The influence of magnetism on ancient construction techniques extends beyond simple alignment. Some researchers speculate that magnetic properties of certain stones may have influenced their selection and placement in megalithic structures. While this theory remains controversial, it highlights the potential for magnetism to have played multiple roles in ancient building practices, from practical navigation to more esoteric purposes. While the ancient Egyptians didn't have levitation technology as we might imagine it today, they did employ ingenious methods that seemed almost magical for their time. The construction of the pyramids likely involved a combination of advanced engineering techniques, including ramps, levers, and counterweights. One theory suggests that the ancient builders may have used water to their advantage. By flooding the area around the base of the pyramid, they could have floated massive stone blocks on wooden rafts. As the water level was raised, the blocks could be maneuvered into place more easily than on dry land. This method would have significantly reduced the friction and weight the workers had to contend with, making the seemingly impossible task more manageable. Another intriguing possibility involves the use of kites or balloon-like devices. Some researchers propose that the Egyptians might have harnessed the power of the wind to lift and move heavy stones. By attaching large kites to the blocks, they could have used the strong desert winds to assist in raising them to great heights. While this might sound far-fetched, it demonstrates the creative thinking required to understand how these ancient wonders were built. These theories, while not true levitation, show how the Egyptians might have used the forces of nature to overcome gravity in ways that would appear almost supernatural to the untrained eye. The true methods used likely combined multiple techniques, showcasing the remarkable ingenuity and problem-solving skills of the ancient Egyptians. Several archaeological discoveries have raised intriguing questions about the technological capabilities of ancient civilizations. In Egypt, precisely cut and polished granite blocks found in structures like the Great Pyramid of Giza exhibit a level of precision that would be challenging to achieve, even with modern tools. Some of these blocks fit together so tightly that a piece of paper cannot be inserted between them, suggesting sophisticated cutting and shaping techniques. The ruins of Pumapunku in Bolivia present another enigma. The site features massive stone blocks with complex, interlocking shapes and precise right angles. These characteristics have led some researchers to speculate about the use of advanced machining methods, as achieving such precision with primitive tools would have been extremely difficult. In ancient Greece, the Antikythera mechanism serves as a remarkable example of early mechanical engineering. This complex geared device, dated to around 150 to 100 BC, was used to calculate astronomical positions and eclipses with astonishing accuracy. Its intricate system of gears and wheels demonstrates a level of mechanical sophistication that was not thought to exist in the ancient world. While these findings do not conclusively prove the existence of advanced machining capabilities in ancient times, they certainly challenge our understanding of early technological development. Researchers continue to study these artifacts, seeking to unravel the methods and tools that might have been used in their creation. Ancient civilizations possessed a remarkable understanding of sound and vibration, which they likely applied to their construction techniques. This knowledge may have helped them create structures with superior acoustic properties and potentially assisted in the movement of massive stone blocks. In ancient amphitheaters, builders used their grasp of sound waves to design spaces with exceptional acoustics. By carefully shaping the seating area and stage, they could ensure that even whispers from performers could be heard clearly throughout the venue. This mastery of sound propagation allowed for the creation of impressive structures that still amaze us today. Some researchers speculate that ancient builders might have used vibration to reduce friction when moving enormous stone blocks. By applying specific frequencies to the stones, they could have created a thin layer of air between the block and the ground, making it easier to slide into place. While this theory remains unproven, it offers an intriguing explanation for how ancient civilizations managed to construct monuments with such precision using seemingly limited technology. Furthermore, the concept of resonance might have played a role in ancient construction techniques. By understanding the natural frequencies of materials and structures, builders could have designed buildings to withstand earthquakes better or even used vibrations to settle foundations more effectively. This application of harmonic principles showcases the sophisticated scientific knowledge our ancestors possessed, challenging our perceptions of ancient capabilities. Ancient Egyptian metalworking techniques have long fascinated archaeologists and engineers, particularly in relation to the construction of the pyramids. One intriguing possibility is the use of advanced copper alloying methods that produce tools far harder and more durable than previously thought possible for that era. These copper alloys may have been used to cut and shape the massive limestone blocks with surprising precision. Another lost technique that could explain some pyramid features is the potential use of electroplating. Some researchers speculate that the ancient Egyptians might have developed a method to apply thin layers of gold or other metals to stone surfaces, creating smooth, reflective finishes on parts of the pyramids that have since weathered away. The ability to cast large metal components with high accuracy is another skill that might have been lost to time. This could explain how certain interlocking stone blocks were fitted so precisely, as metal frames or guides could have been used during construction to ensure perfect alignment. Lastly, metallurgical analysis of ancient Egyptian artifacts has revealed sophisticated welding techniques that could have been employed in creating specialized tools for pyramid construction. These welding methods, combined with potential heat treatment processes, might have produced tools capable of working with even the hardest stones used in the pyramids. Some unconventional theorists propose that ancient Egyptians possessed advanced knowledge of gravity manipulation, allowing them to construct massive structures like the pyramids with seemingly impossible precision and ease. These ideas, while not supported by mainstream archaeology, suggest that the Egyptians might have used acoustic levitation techniques to move and position enormous stone blocks. The theory posits that by using a combination of sound waves at specific frequencies, the ancient builders could have created a localized disruption in the gravitational field. This disruption would theoretically reduce the effective weight of massive stone blocks, making them easier to transport and maneuver into place. Proponents of this idea point to certain hieroglyphs and ancient texts that they interpret as descriptions of advanced technologies. They argue that these texts, when viewed through a modern scientific lens, could be explaining principles of acoustic physics and gravity manipulation. However, it is crucial to note that these theories lack substantial evidence and are not accepted by the scientific community. Mainstream archaeologists and physicists maintain that the impressive feats of ancient Egyptian construction were achieved through ingenious but conventional methods, including ramps, levers, and a profound understanding of mathematics and engineering principles. The construction of the Great Pyramids and Stonehenge represent two remarkable feats of ancient engineering, each with its own unique challenges and solutions. The pyramids of Egypt, built around 4,500 years ago, required precise planning and execution on a massive scale. Enormous limestone blocks were quarried, transported, and stacked with incredible accuracy to form the iconic triangular shape we know today. In contrast, Stonehenge, erected in several stages between 4,500 and 3,500 years ago, involved transporting massive stones over long distances and arranging them in a circular pattern. The blue stones used in Stonehenge were brought from quarries over 150 miles away, a monumental task for ancient builders. Both structures relied on sophisticated knowledge of geometry and astronomy. The pyramids were aligned with incredible precision to the cardinal points, while Stonehenge was designed to align with solar and lunar events. However, the pyramids required more advanced mathematics to achieve their precise angles and smooth sides. The tools used also differed significantly. Egyptian builders likely used copper chisels, bronze saws, wooden rollers and sleds, ramps and levers to cut and move their stone blocks. Stonehenge builders, working with harder stone, probably used stone hammers and chisels, along with ropes, wooden rollers and sleds for transport. Both projects demonstrate the ingenuity and determination of our ancestors in creating enduring monuments that continue to captivate us millennia later. The Great Pyramids of Egypt and ancient structures in South America share remarkable similarities despite being separated by vast distances and time. Both civilizations constructed massive pyramid-like monuments that have endured for millennia, showcasing advanced engineering and astronomical knowledge. In both regions, these structures often served as tombs or religious centers, demonstrating the importance of spiritual beliefs in ancient societies. The precision of construction is another common feature, with many of these buildings aligned to celestial events, such as solstices or equinoxes. This alignment suggests a deep understanding of astronomical cycles and their significance in both cultures. Another intriguing parallel is the use of advanced stone cutting and fitting techniques. Both Egyptian and South American builders created structures with incredibly tight-fitting stone blocks, often without the use of mortar. This level of precision has puzzled modern engineers and archaeologists, leading to ongoing debates about the methods used to achieve such remarkable results. The sheer scale of these monuments also points to sophisticated social organization and labor management in both regions. Building such massive structures required extensive planning, resource allocation, and coordination of large workforces, indicating complex and well-developed societies in both ancient Egypt and South America. The Great Pyramids of Giza stand as a testament to the incredible engineering prowess of ancient Egyptians. Built around 4,500 years ago, these massive structures showcase a level of precision that continues to astound modern architects and engineers. The base of the Great Pyramid of Khufu is level to within just a few centimeters across its entire 430-meter width, an achievement that would be challenging even with today's advanced technology. In terms of scale, The Great Pyramid originally stood at a height of 146 meters, making it the tallest human-made structure for over 3,800 years. This dwarfed other ancient wonders like the Hanging Gardens of Babylon or the statue of Zeus at Olympia. The sheer volume of stone used in its construction, estimated at 2.3 million blocks, far surpasses that of any other ancient monument. The precision of the Great Pyramids is particularly evident in their alignment. The sides of the Great Pyramid are aligned to the cardinal directions with remarkable accuracy, deviating by less than 1/10 of a degree. This level of astronomical alignment is unmatched by other ancient wonders and speaks to the advanced knowledge of the Egyptian builders. When compared to other ancient wonders, the Great Pyramids stand out not only for their size but also for their longevity. While structures like the Colossus of Rhodes and the Lighthouse of Alexandria have long since crumbled, the pyramids have endured for millennia, a testament to the superior construction techniques and materials used by the ancient Egyptians. This combination of scale, precision, and durability sets the Great Pyramids apart as truly exceptional among the wonders of the ancient world. Ancient structures across different continents often reveal surprising similarities, and the Great Pyramids of Egypt share several common features with ancient structures in Asia. One striking parallel is the use of precise stone cutting and fitting techniques. Both Egyptian and Asian builders demonstrated remarkable skill in shaping and aligning massive stone blocks with incredible accuracy, often without the use of mortar. Another shared characteristic is the emphasis on astronomical alignment. Many ancient structures, including the Great Pyramids and temples in Asia, were carefully oriented to celestial bodies or events. This suggests a common interest in observing and recording celestial movements across ancient civilizations. The concept of a stepped pyramid design is also found in both regions. While the Great Pyramids have smooth sides, earlier Egyptian pyramids were stepped, similar to many ancient Asian structures like the ziggurats of Mesopotamia and some temple complexes in Southeast Asia. Furthermore, both Egyptian and Asian ancient structures often incorporated intricate internal chambers and passageways. These complex interior designs served various purposes, from burial chambers to religious rituals, reflecting a shared emphasis on creating spaces for spiritual and ceremonial activities within these monumental buildings. The Great Pyramids of Egypt and Roman architecture represent two remarkable periods of ancient engineering, each with its own distinct characteristics and achievements. The pyramids, built around 4,500 years ago, stand as colossal monuments to precision and ingenuity. These massive structures were constructed using limestone blocks weighing up to 70 tons, stacked with incredible accuracy. The ancient Egyptians achieved near-perfect alignment with true north and created smooth, flat faces on the pyramid sides, showcasing their advanced understanding of geometry and astronomy. Roman architecture, flourishing over 2,000 years later, brought its own set of innovations. The Romans mastered the use of concrete, a material that allowed them to create large, durable structures like the Pantheon with its impressive dome. They developed the arch, which enabled them to build expansive bridges and aqueducts that transported water over long distances. Roman roads, many of which still exist today, demonstrate their skill in civil engineering and urban planning. While the pyramids focus on sheer scale and precision in a single, monumental form, Roman architecture emphasizes versatility and functionality across various types of structures. The Romans excelled in creating practical, long-lasting buildings and infrastructure that served the needs of a vast empire. Their use of standardized designs and materials allowed for rapid construction across diverse geographical areas. Both civilizations displayed remarkable problem-solving skills. The Egyptians overcame the challenge of building at an unprecedented scale, while the Romans tackled the complexities of urban living and imperial expansion. These ancient engineering marvels continue to inspire and amaze us, offering insights into the ingenuity of our ancestors and the evolution of construction techniques over time. Ancient structures across the globe often reveal surprising connections, and the parallels between the Great Pyramids of Egypt and ancient structures in North America are particularly intriguing. Both civilizations, separated by vast distances and time, developed impressive architectural skills to create monumental structures that have endured for millennia. In North America, the Cahokia Mounds in present-day Illinois stand as a testament to the advanced engineering capabilities of ancient Native American cultures. Like the Great Pyramids, these earthen mounds were constructed as stepped structures, with the largest, known as Monk's Mound, reaching a height of 100 feet. Both the Egyptian pyramids and Cahokia mounds served as focal points for their respective societies, combining religious, political, and cultural significance. The precision of construction is another shared characteristic. While the Great Pyramids are renowned for their exact alignment with cardinal directions, many North American mounds also demonstrate careful orientation to celestial events. This suggests that both cultures possessed advanced astronomical knowledge and incorporated it into their architectural designs. Furthermore, both the Egyptian pyramids and North American mounds often contained burial chambers and artifacts, indicating their role in funerary practices and beliefs about the afterlife. These similarities in purpose and design highlight the universal human drive to create lasting monuments that connect the earthly realm with the divine, transcending geographical boundaries and cultural differences. The Great Pyramids of Giza exhibit remarkable astronomical alignments that have fascinated researchers for centuries. These massive structures are oriented with astonishing precision to the cardinal directions, with the sides of their square bases aligned almost perfectly north, south, and east-west. The deviation from true north is less than 1/10 of a degree, a feat that showcases the ancient Egyptians' advanced understanding of celestial observations and surveying techniques. Comparatively, other ancient sites around the world also demonstrate impressive astronomical alignments, though often in different ways. Stonehenge in England, for instance, is famously aligned with the summer solstice sunrise. The Mayan city of Chichen Itza features a pyramid known as El Castillo, which is designed so that during the spring and autumn equinoxes, the sunlight creates the illusion of a serpent descending the stairs. In South America, the Incan city of Machu Picchu incorporates various astronomical alignments. Its Intihuatana stone, often called the hitching post of the sun, is positioned to mark the two equinoxes. Similarly, the Aztec Templo Mayor in Mexico City was built to align with the rising point of the Pleiades star cluster. While many ancient sites show evidence of astronomical knowledge, the precision of the Great Pyramids stands out. Their accuracy in alignment surpasses that of most other ancient structures, highlighting the extraordinary skill and celestial understanding of their builders. This precision, combined with their massive scale, continues to inspire awe and scientific inquiry into the methods and knowledge of ancient civilizations. While the Great Pyramids of Egypt and Göbekli Tepe in Turkey were built thousands of years apart, they share some intriguing similarities in their construction techniques. Both structures demonstrate remarkable precision in stone cutting and placement, showcasing the advanced capabilities of ancient builders. One notable similarity is the use of massive stone blocks. The builders of both sites managed to quarry, transport, and position enormous stones with astonishing accuracy. At Göbekli Tepe, T-shaped pillars weighing up to 20 tons were erected and arranged in circular patterns. Similarly, the Great Pyramids feature limestone blocks weighing several tons each, stacked with incredible precision. Another shared technique is the absence of mortar in critical parts of the structures. The stones at both sites were cut so precisely that they fit together snugly without the need for binding material. This level of craftsmanship speaks to the sophisticated knowledge and skills possessed by these ancient civilizations. Both sites also exhibit evidence of careful planning and astronomical alignment. The Great Pyramids are famously aligned with cardinal directions, while some researchers suggest that Göbekli Tepe's circular enclosures may have been oriented to track celestial events. This attention to cosmic alignments hints at the importance of astronomy in ancient construction practices across different cultures and time periods. The Great Pyramids of Egypt stand as remarkable feats of ancient engineering, primarily constructed from massive limestone blocks quarried from nearby sources. These enormous structures also incorporated granite, particularly for specific elements like inner chambers and support beams. The ancient Egyptians transported these immense stones, some weighing up to 70 tons, using sophisticated techniques that continue to intrigue modern engineers. In contrast, other ancient megastructures often utilized a wider variety of materials. The ziggurats of ancient Mesopotamia, for instance, were typically built using mud bricks as their primary component, with an outer layer of fired bricks for added durability. This choice of material reflected the resources available in the region and the specific architectural style of these stepped pyramid structures. The ancient Mayan and Aztec pyramids in Central America employed a different approach, often using a combination of limestone blocks and rubble fill. These structures frequently featured intricate stone carvings and were adorned with colorful stucco, creating a visually striking appearance quite different from the smooth, angled surfaces of the Egyptian pyramids. In Asia, the Great Wall of China represents another monumental ancient construction built using a mixture of rammed earth, stone, and brick. The materials varied depending on the specific section and the local resources available, showcasing the adaptability of ancient builders to their environment. This diversity in construction materials across different civilizations highlights the ingenuity and resourcefulness of ancient engineers in creating lasting monuments with the materials at hand. Ancient civilizations across the globe have left us remarkable structures that continue to intrigue and amaze. The Great Pyramids of Egypt share several common symbols and motifs with other ancient sites worldwide, suggesting possible connections or parallel developments in human culture and understanding. One striking similarity is the use of astronomical alignments. The Great Pyramids are precisely aligned with cardinal directions, and their layout corresponds to the pattern of stars in Orion's belt. This celestial connection is mirrored in sites like Stonehenge in England and the Mayan pyramids in Central America, which also demonstrate sophisticated astronomical knowledge. The symbol of the serpent appears frequently in Egyptian iconography and is also prominent in ancient sites across the Americas, such as the Aztec Templo Mayor and the Mayan Chichen Itza. This recurring motif might represent wisdom, renewal, or cosmic energy across different cultures. Geometric patterns and the use of sacred numbers are another shared feature. The proportions and measurements of the Great Pyramids incorporate the golden ratio, a mathematical concept found in nature. Similar precise geometric principles are evident in structures like the Parthenon in Greece and various Hindu temples in India, suggesting a universal appreciation for mathematical harmony in ancient architecture. The idea that the Great Pyramid of Giza was a functional machine is a controversial theory that lacks substantial scientific evidence. While some alternative researchers have proposed this concept, mainstream archaeologists and Egyptologists do not support it. The Great Pyramid is widely accepted as a monumental tomb built for the pharaoh Khufu during the Old Kingdom period of ancient Egypt, around 2560 BCE. Archaeological evidence strongly supports the tomb theory. The pyramid contains internal chambers and passages consistent with burial practices of the time, including the king's chamber, which housed a sarcophagus. Hieroglyphic inscriptions and ancient Egyptian texts also corroborate the pyramid's purpose as a royal tomb. The construction techniques used in building the Great Pyramid are well documented and align with known ancient Egyptian engineering practices. The pyramid's precise alignment with cardinal directions and its sophisticated architectural features demonstrate the advanced knowledge and skills of its builders, but these elements do not necessarily indicate it was a machine. Some proponents of the machine theory point to the pyramid's unique internal structure, such as its shafts and chambers, as evidence of a functional purpose beyond a tomb. However, these features can be explained by religious and symbolic significance in ancient Egyptian culture, as well as practical construction and engineering considerations of the time. The idea of the Great Pyramid of Giza functioning as an energy generator is a controversial and unproven theory that has gained traction in some alternative science circles. While mainstream archaeology and Egyptology do not support this concept, proponents of the theory suggest that the pyramid's unique structure and materials could have allowed it to harness and concentrate electromagnetic energy from the Earth and atmosphere. According to this speculative theory, the limestone blocks used in the pyramid's construction, which contain traces of quartz crystal and other minerals, might have been able to capture and channel electromagnetic waves. The internal chambers and passageways of the pyramid, particularly the king's chamber, are thought by some to have acted as resonance chambers, potentially amplifying and focusing this energy. Some advocates of this theory point to the pyramid's precise alignment with the cardinal directions and its location near the Earth's equator as factors that could have enhanced its hypothetical energy-gathering capabilities. They also suggest that the pyramid's original smooth, polished limestone casing, now mostly absent, might have played a role in this process by creating a more efficient surface for energy collection. It is important to note that these ideas are not accepted by the scientific community and lack empirical evidence. The prevailing archaeological consensus is that the Great Pyramid was built as a monumental tomb for the pharaoh Khufu, serving religious and cultural purposes rather than technological ones. While the ancient Egyptians demonstrated remarkable engineering skills in constructing the pyramids, there is no solid evidence to support the notion of their use as energy generators. The Great Pyramid of Giza has long fascinated researchers, and some have proposed unconventional theories about its purpose. One such theory suggests it might have functioned as a water pump. Proponents of this idea point to several features of the pyramid's internal structure. The subterranean chamber, located deep beneath the pyramid, contains a pit that some theorists believe could have been used to collect groundwater. The descending passage leading to this chamber is precisely angled, which some argue could have facilitated water flow. Additionally, the Grand Gallery, with its corbelled design, has been likened to a ram pump, a type of hydraulic pump that uses the water hammer effect to move water upward. The Queen's Chamber, situated above the subterranean chamber, contains two shafts that extend towards the pyramid's exterior. These shafts, sealed at both ends, have puzzled archaeologists for years. Some proponents of the water pump theory suggest these could have been used to channel water or create necessary pressure differentials. However, it is crucial to note that mainstream archaeologists and Egyptologists do not support this theory. The consensus among experts remains that the Great Pyramid was built as a tomb for the pharaoh Khufu. The internal chambers and passages are generally understood to have religious and symbolic significance related to ancient Egyptian beliefs about the afterlife. Some researchers have proposed an intriguing theory about the Great Pyramid of Giza, suggesting it might have served as a sophisticated communication device. They speculate that the pyramid's unique internal structure, particularly its system of shafts and chambers, could have been designed to harness and amplify sound waves. The theory posits that the king's chamber, located deep within the pyramid, might have acted as a resonance chamber. The granite walls and ceiling of this room could potentially amplify and focus sound waves. The narrow shafts leading from this chamber to the exterior of the pyramid might then have been used to transmit these amplified sounds over long distances. Proponents of this idea suggest that low-frequency sounds, perhaps generated by striking the granite coffer in the king's chamber, could travel through these shafts and be projected outward. In theory, this could allow for long-distance communication, possibly even between different pyramids or ancient Egyptian cities. While this hypothesis is certainly fascinating, it remains highly speculative and is not widely accepted in the scientific community. Traditional archaeological evidence supports the primary function of the Great Pyramid as a tomb for the pharaoh Khufu. Nevertheless, this theory highlights the ongoing mystery and allure of the pyramids, prompting us to continue exploring and questioning our understanding of these ancient marvels. There is no credible scientific evidence suggesting the Great Pyramid of Giza was a beacon for extraterrestrial communication. This idea stems from pseudo-scientific theories and misinterpretations of ancient Egyptian culture and technology. The Great Pyramid, built around 2560 BCE, was constructed as a tomb for pharaoh Khufu. Its design and construction methods, while impressive, are well understood by archaeologists and engineers. The pyramid's shape and alignment were likely chosen for religious and practical reasons related to ancient Egyptian beliefs about the afterlife and the technology available at the time. Some have pointed to the pyramid's precise alignment with cardinal directions as evidence of advanced knowledge, but this can be explained by ancient Egyptian astronomical observations and surveying techniques. The pyramid's internal chambers and passages, sometimes cited as mysterious, actually serve clear purposes related to burial practices and religious beliefs of the time. Modern archaeological research continues to reveal new insights about the Great Pyramid's construction and purpose, all of which point to human ingenuity rather than extraterrestrial involvement. The pyramid stands as a testament to the remarkable achievements of ancient human civilization, not as evidence of alien contact. The Great Pyramid of Giza, an architectural marvel of the ancient world, has long fascinated researchers with its precise construction and mysterious internal chambers. Some unconventional theories suggest that its intricate network of passages and chambers might have served as a form of ancient computational device. The pyramid's internal structure features a complex system of corridors, shafts, and chambers that could potentially have been used to process and store information. The Grand Gallery, with its precise angle and smooth surfaces, might have acted as a mechanism for tracking celestial movements. The Queen's Chamber and King's Chamber, positioned at specific heights within the pyramid, could have functioned as data processing units, utilizing the unique resonant properties of their granite construction. Proponents of this theory argue that the pyramid's internal layout could have enabled ancient Egyptians to perform complex calculations related to astronomy, agriculture, and timekeeping. The narrow shafts leading from the chambers to the exterior of the pyramid might have served as input and output channels for information, possibly aligning with specific stars or constellations at certain times of the year. While these ideas are intriguing, it is important to note that they remain speculative and are not widely accepted by mainstream archaeologists or Egyptologists. The prevailing view is that the Great Pyramid was primarily a tomb for the pharaoh Khufu, with its internal structure designed for religious and funerary purposes rather than computational functions. Some fringe theorists have suggested that the Great Pyramid of Giza might have been used for weather control, though these ideas are not supported by mainstream archaeology or science. One such theory proposes that the pyramid's shape and internal structure could have been designed to generate and manipulate electromagnetic energy, potentially influencing atmospheric conditions. Proponents of this idea claim that the pyramid's limestone blocks and granite chambers could have acted as piezoelectric generators, converting mechanical stress into electrical energy. Another speculative theory suggests that the Great Pyramid might have functioned as a device to collect and concentrate atmospheric ions, supposedly allowing ancient Egyptians to manipulate local weather patterns. Some proponents of this idea point to the pyramid's original smooth, polished limestone casing as a potential conductor for atmospheric electricity. It is important to note that these theories lack scientific evidence and are not accepted by the archaeological community. Extensive research and excavations have consistently shown that the Great Pyramid was built as a tomb for the pharaoh Khufu, serving as his final resting place, and a symbol of ancient Egyptian religious beliefs and architectural prowess. Mainstream Egyptology explains the pyramid's unique features, such as its precise alignment and internal chambers, as part of its funerary and symbolic functions rather than for any weather control purposes. The enduring fascination with alternative theories about the Great Pyramid speaks to its impressive engineering and the human desire to find extraordinary explanations for ancient achievements. The Great Pyramid of Giza, an ancient marvel of engineering, might have functioned as a sophisticated astronomical observatory. Its precise alignment with the cardinal directions suggests a deep understanding of celestial movements. The pyramid's northern shaft aligns perfectly with the North Star as it appeared during its construction, allowing ancient Egyptians to track its position throughout the year. The structure's smooth, angled sides could have served as precise markers for solar observations. During equinoxes, the sun would cast no shadow on the pyramid at noon, providing a clear indicator of these important celestial events. This feature allowed the Egyptians to accurately determine the length of the solar year and create their complex calendar system. Furthermore, The pyramid's design incorporated specific angles that aligned with significant star positions. The southern shaft of the king's chamber, for instance, pointed towards the constellation Orion, which held great religious significance in ancient Egyptian culture. These alignments enabled priests and astronomers to track the movements of celestial bodies and predict important astronomical events. The Great Pyramid's role as an astronomical observatory highlights the advanced scientific knowledge of ancient Egyptians. It demonstrates their ability to integrate complex astronomical observations into monumental architecture, creating a structure that served both as a tomb for the pharaoh and a tool for understanding the cosmos. There is no credible scientific evidence supporting the idea that the Great Pyramid of Giza was a device for manipulating time. This concept is purely speculative and falls into the realm of pseudoscience rather than established historical or archaeological fact. The Great Pyramid, built during the reign of Pharaoh Khufu around 2560 BCE, was constructed as a monumental tomb. Archaeological evidence, including ancient Egyptian texts and artifacts found within the pyramid complex, clearly indicates its purpose as a burial site for the pharaoh and his possessions for the afterlife. The pyramid's precise construction and alignment with cardinal directions demonstrate the ancient Egyptians' advanced knowledge of mathematics, astronomy, and engineering. However, these features were likely related to religious and cultural beliefs about the afterlife, rather than any form of time manipulation. Theories about time, manipulation, or other extraordinary purposes for the Great Pyramid are not supported by mainstream archaeology or physics. Such ideas often misinterpret or exaggerate the pyramid's features, ignoring the wealth of evidence about its actual purpose and construction methods. The Great Pyramid of Giza has long fascinated researchers and spiritual seekers alike, with some proposing that it may have served as more than just a tomb for the pharaoh Khufu. One intriguing theory suggests that the pyramid could have functioned as a device for spiritual enlightenment. The unique geometry and precise alignment of the Great Pyramid have led some to speculate about its potential metaphysical properties. The structure's shape, with its perfect square base and triangular sides meeting at a single point, has been thought to focus and amplify energy. This concentration of energy, some believe, could have been used to facilitate altered states of consciousness or spiritual experiences. Another aspect of the pyramid that supports this theory is its internal chamber system. The king's chamber, located deep within the pyramid, features walls made of granite, a material known for its piezoelectric properties. Some researchers propose that this chamber could have acted as a resonance chamber, amplifying specific frequencies that might induce meditative or transcendent states. The pyramid's alignment with cardinal directions and certain celestial bodies has also fueled speculation about its spiritual purpose. Some theorists suggest that this precise orientation allowed the structure to harness cosmic energies, potentially facilitating a connection between the physical and spiritual realms. While these ideas remain speculative, they continue to inspire exploration into the possible esoteric functions of this ancient wonder. The precision of the right angles in the Great Pyramid of Giza is truly remarkable, especially considering it was built over 4,500 years ago. The ancient Egyptians achieved an astonishing level of accuracy in constructing this massive monument. The right angles at the base of the pyramid are incredibly close to a perfect 90 degrees, with an average error of less than 1/20th of a degree. This level of precision becomes even more impressive when we consider the sheer scale of the structure. The Great Pyramid originally stood at a height of about 146 meters, with a base covering an area of more than 5 hectares. Achieving such accuracy over such a large scale without modern surveying equipment is a testament to the advanced knowledge and skills of the ancient Egyptian builders. The accuracy of these angles contributes to the overall symmetry and stability of the pyramid. It allows the structure to distribute its immense weight evenly, which is one reason why the Great Pyramid has endured for millennia. This precision also plays a role in creating the perfect triangular shape that has captivated people for generations. The methods used by the ancient Egyptians to achieve this level of accuracy remain a subject of ongoing research and debate among archaeologists and engineers. Some theories suggest they may have used sophisticated surveying techniques involving the stars, while others propose ingenious uses of water levels and plumb bobs. Regardless of the exact methods, the result stands as a monumental achievement in ancient architecture and engineering. The ancient Egyptians built the Great Pyramid of Giza with a remarkable height-to-base ratio that has fascinated scholars for centuries. This ratio closely approximates the mathematical constant pi, which is the ratio of a circle's circumference to its diameter. The pyramid's original height was about 146 meters, while its base measured about 230 meters on each side. When we divide the pyramid's perimeter by twice its height, we get a value very close to pi. This near-perfect embodiment of pi in the pyramid's proportions raises intriguing questions about the mathematical knowledge of ancient Egyptian architects. Some researchers suggest this could not be mere coincidence, indicating that the builders possessed a sophisticated understanding of geometry and mathematical principles. However, others argue that the Egyptians might have arrived at these proportions through practical experience and aesthetic preferences rather than abstract mathematical concepts. The significance of this ratio extends beyond mathematics. It demonstrates the precision and skill of ancient Egyptian engineering and construction techniques. Building a massive structure with such accurate proportions required extensive planning, advanced tools, and a deep understanding of architectural principles. This achievement becomes even more impressive considering the limited technology available over 4,000 years ago. Furthermore, the pyramid's proportions contribute to its structural stability and visual appeal. The specific ratio allows the pyramid to distribute its enormous weight efficiently, helping it withstand the test of time. This enduring design has inspired architects and engineers throughout history, influencing the construction of modern buildings and monuments worldwide. The Great Pyramid of Giza stands as a testament to the incredible engineering skills of the ancient Egyptians. The precision of its base leveling is truly remarkable, especially considering it was built over 4,500 years ago without modern surveying equipment. The base of the Great Pyramid is astonishingly flat. Measurements have shown that the difference in height between the highest and lowest points of the base is less than 1 inch over its entire 456-foot width. This level of accuracy is comparable to that achieved in modern building construction using laser levels and advanced technology. To put this precision into perspective, if we were to scale up the Great Pyramid to the size of Earth, the largest deviation in its base would be equivalent to the height of a small hill. This extraordinary feat of engineering demonstrates the ancient Egyptians' mastery of geometry and their meticulous attention to detail. The flattening of the pyramid's base was crucial for its structural integrity and longevity. This precise leveling has contributed to the pyramid's ability to withstand earthquakes, wind erosion, and the passage of time for millennia, remaining the oldest and only surviving wonder of the ancient world. The ancient Egyptians employed a sophisticated system of measurement in constructing the Great Pyramid of Giza. Their primary unit of length was the royal cubit, which was approximately 52.4 centimeters in modern measurements. This standard was derived from the length of a forearm, from elbow to the tip of the middle finger, providing a practical and easily replicable unit for the workers. Subdivisions of the royal cubit were also used for more precise measurements. The palm, equal to 1/7 of a royal cubit, and the digit, 1/28 of a royal cubit, allowed for increasingly fine adjustments. These smaller units were crucial for the intricate stonework and precise alignments required in pyramid construction. The ancient builders also utilized a unit called the seekt to measure slopes and angles. This ingenious system expressed the horizontal distance traveled for a vertical rise of 1 cubit. The Great Pyramid's seekt was 5½ palms, creating its iconic 52-degree slope. Remarkably, the consistency of these measurements throughout the massive structure of the Great Pyramid demonstrates the ancient Egyptians' advanced understanding of geometry and their ability to maintain precise standards across a monumental construction project. Their meticulous approach to measurement, contributed significantly to the enduring accuracy and stability of this wonder of the ancient world. The Great Pyramid of Giza, an ancient wonder that has captivated humanity for millennia, holds a surprising connection to our planet's dimensions. When we measure the perimeter of the Great Pyramid's base, we find it equals exactly 1/2 minute of longitude at the equator. This means that if we multiply the pyramid's perimeter by 60 times 60, we arrive at the polar circumference of the Earth. This remarkable correspondence has led many to question whether the ancient Egyptians possessed advanced knowledge of our planet's size and shape. However, mainstream archaeologists and historians generally view this relationship as a coincidence rather than evidence of ancient advanced science. They argue that the ancient Egyptians likely did not have the means to accurately measure the Earth's circumference. Nevertheless, this mathematical relationship continues to intrigue researchers and enthusiasts alike. It serves as a testament to the precision of ancient Egyptian engineering and construction techniques. The builders of the Great Pyramid achieved a level of accuracy that allows for such comparisons to be made thousands of years later. This connection between the Great Pyramid and the Earth's circumference also highlights the ongoing fascination with ancient structures and their potential hidden meanings. It reminds us that there is still much to learn about the knowledge and capabilities of ancient civilizations and how they viewed their place in the cosmos. The ancient Egyptians achieved a remarkable feat of engineering and astronomical precision when they constructed the Great Pyramid of Giza. This massive structure is aligned with true north to an astonishing degree of accuracy, with an error of less than 1/10 of 1 degree. This alignment is not mere coincidence, but a testament to the advanced knowledge and skills of the ancient builders. The significance of this alignment lies in its implications for ancient Egyptian culture, technology, and understanding of the cosmos. It suggests that the builders possessed sophisticated methods for determining true north, likely involving careful observations of the night sky. They may have used the circumpolar stars, which appear to rotate around the celestial North Pole, as a reference point for their calculations. This precise alignment also had practical purposes. It allowed the ancient Egyptians to create accurate sundials and calendars, which were crucial for agricultural planning and religious ceremonies. The pyramid's alignment with true north might have also held spiritual significance, potentially symbolizing the pharaoh's connection to the cosmic order and the afterlife. Furthermore, this achievement has profound implications for our understanding of ancient civilizations. It challenges preconceptions about the technological capabilities of early societies and prompts us to reconsider the depth of their astronomical knowledge. The pyramid's alignment continues to intrigue scientists and historians, serving as an enduring reminder of the ingenuity and astronomical expertise of our ancient ancestors. The stone blocks in the Great Pyramid of Giza display an astonishing level of precision that continues to impress modern engineers and archaeologists. The ancient Egyptian builders achieved a degree of accuracy that seems almost impossible for their time, over 4,500 years ago. The limestone blocks forming the core of the pyramid were cut with remarkable consistency, typically measuring about 1 meter high and over 2 meters long. However, it is the casing stones that once covered the entire structure that truly showcase the builder's skill. These outer limestone blocks were cut to within fractions of a millimeter, fitting together so tightly that it is often impossible to slide even a thin knife blade between them. This precision extends beyond just the cutting of individual blocks. The entire structure of the Great Pyramid demonstrates incredible accuracy in its overall shape and alignment. The base of the pyramid is almost perfectly level, with a maximum deviation of only 15 millimeters across its entire 430-meter perimeter. This feat is made even more impressive considering the pyramid was built on uneven bedrock. The ancient Egyptians achieved this level of precision using copper chisels, bronze saws, wooden rollers and sleds, ramps and levers. They also employed sophisticated surveying and leveling tools to ensure accuracy in the pyramid's construction. This exceptional craftsmanship has allowed the Great Pyramid to endure for millennia, standing as a testament to the skill and ingenuity of its builders. The Great Pyramid of Giza has long fascinated scholars and enthusiasts alike, not just for its impressive size and construction, but also for the mathematical relationships found in its dimensions. One of the most intriguing aspects is the apparent encoding of the mathematical constant pi. The ratio of the pyramid's perimeter to its height is very close to 2 times pi, suggesting a deliberate incorporation of this fundamental constant. Another mathematical relationship observed in the Great Pyramid involves the golden ratio, also known as phi. This ratio, approximately equal to 1.618, appears in various aspects of the pyramid's design, including the proportions of its faces and internal chambers. Some researchers argue that these relationships are too precise to be coincidental, indicating a sophisticated understanding of mathematics by the ancient Egyptians. It's important to note that while these mathematical constants are indeed present in the pyramid's dimensions, the debate continues about whether they were intentionally incorporated or are simply a result of practical construction methods. Some scholars argue that the ancient Egyptians used a simple system of proportions that naturally led to these mathematical relationships, rather than explicitly trying to encode specific constants. Regardless of the intent, the presence of these mathematical relationships in such an ancient and monumental structure continues to inspire awe and curiosity, serving as a testament to the ingenuity and skill of the ancient Egyptian builders. The Great Pyramid of Giza, an ancient wonder that has captivated humanity for millennia, demonstrates a remarkable level of astronomical precision. Its builders achieved astonishing accuracy in aligning the structure with the cardinal directions of north, south, east, and west. The north-south axis of the Great Pyramid is aligned to true north, with an error of less than 1/10 of 1 degree, a feat that would challenge even modern surveyors using advanced equipment. This precision extends beyond simple compass directions. The descending passage within the pyramid points directly to the north celestial pole, the point in the sky around which the stars appear to rotate. At the time of its construction, this alignment would have pointed almost exactly to the star Thuban, which was then the North Star. The pyramid's eastern and western sides are also aligned to the equinoxes, the 2 days each year when day and night are of equal length worldwide. During these events, the sun appears to set exactly halfway between the pyramid's north and south sides when viewed from the Sphinx. This alignment suggests a deep understanding of solar movements and their annual cycles. Such accuracy in astronomical alignments raises intriguing questions about the ancient Egyptians' knowledge of astronomy and their surveying capabilities. It demonstrates that they possessed sophisticated observational skills and a profound understanding of celestial mechanics, challenging our perceptions of ancient scientific knowledge and engineering prowess. The Great Pyramid of Giza, an ancient marvel of engineering, continues to astound us with its precision and mathematical sophistication. The angle of its sides, approximately 51.5 degrees, is not a random choice but a carefully calculated design feature. This specific angle allows the pyramid to rise with a perfect slope, creating a structure that has endured for millennia. This angle is significant because it results in the pyramid having a unique mathematical property. When we measure the ratio of the pyramid's height to half its base length, we find it is remarkably close to the mathematical constant pi. This relationship suggests that the ancient Egyptians possessed advanced mathematical knowledge, perhaps even understanding concepts that would not be formally described until thousands of years later. Moreover, this precise angle ensures that the pyramid's faces form nearly perfect equilateral triangles. This geometric perfection contributes to the structure's stability and its ability to withstand the forces of nature for over 4,000 years. The angle also plays a crucial role in the pyramid's function as a solar marker, allowing it to cast specific shadows at important times of the year. The significance of this angle extends beyond mathematics and engineering. It has fueled centuries of speculation about the purpose and meaning of the Great Pyramid, leading to theories ranging from astronomical observatories to energy-focusing devices. While many of these ideas remain in the realm of speculation, the precision of the pyramid's construction continues to inspire awe and scientific inquiry to this day. Ancient Egyptians relied heavily on copper tools during the construction of their magnificent pyramids. Copper chisels were essential for shaping and cutting limestone blocks, the primary building material for these monumental structures. These chisels, crafted from copper alloys, were remarkably effective for carving and refining the stone surfaces. Copper saws also played a crucial role in the building process. These long, toothed blades allowed workers to cut through softer stones and create precise edges. Additionally, copper adzes, resembling a combination of an axe and a hoe, were used for smoothing surfaces and shaping wooden components used in construction. Another important copper tool was the grappling hook, which aided in moving and positioning large stone blocks. These hooks, attached to ropes, provided leverage and control during the precise placement of massive limestone pieces. Copper hammers and mallets were employed for more delicate work, such as creating intricate details in temple decorations within the pyramid complexes. It's worth noting that while copper tools were softer than modern steel implements, they were well suited for working with limestone. The ancient Egyptians would frequently sharpen these tools to maintain their effectiveness throughout the long and arduous pyramid building process. Ancient Egyptian bronze tools were surprisingly effective in cutting and shaping granite, despite the considerable hardness of this igneous rock. Bronze, an alloy of copper and tin, was the primary metal used for tools in ancient Egypt before the widespread adoption of iron. While bronze is softer than granite, the Egyptians developed ingenious techniques to overcome this limitation. One key method involved using bronze saws in conjunction with abrasive materials like quartz sand. The sand particles, being harder than bronze but softer than granite, acted as the cutting agent. Bronze saws would trap these abrasive grains, allowing them to wear away the granite slowly but steadily. This process, though time-consuming, proved remarkably effective for cutting large blocks and creating precise shapes. Additionally, ancient Egyptians employed bronze chisels and hammers for more detailed work. These tools were used in combination with wooden wedges and water. Craftsmen would drill a series of holes in the granite, insert wooden wedges, and soak them with water. As the wood expanded, it created pressure that helped split the stone along desired lines. The effectiveness of these bronze tools is evident in the monumental structures and intricate sculptures that have survived for millennia. From the precisely cut blocks of the Great Pyramid to the finely carved statues of pharaohs, the ancient Egyptians demonstrated a mastery of granite working that continues to impress modern engineers and archaeologists. Contrary to popular belief, there is no conclusive evidence for the use of diamond-tipped drills in ancient Egypt. This misconception likely stems from the impressive precision and craftsmanship observed in Egyptian stonework, which has led to speculation about advanced tools and techniques. Archaeological findings and historical records indicate that ancient Egyptians primarily used copper chisels, bronze saws, and stone hammers for their stonework. They also employed wooden rollers and sleds to transport heavy stones and used sophisticated techniques like levering and ramping to maneuver massive blocks into place. One particularly intriguing method involved using wooden wedges. These wedges were inserted into cracks in the stone and then soaked with water. As the wood expanded, it created pressure that split the rock along its natural fault lines. This technique, combined with their deep understanding of geology and meticulous planning, allowed the Egyptians to achieve remarkable precision in their stone cutting. Recent experiments have demonstrated that copper tools, when combined with abrasive materials like sand, can indeed cut through hard stones like granite. This suggests that the ancient Egyptians could have achieved their impressive results using relatively simple tools and a great deal of skill and patience rather than advanced technologies like diamond-tipped drills. The ancient Egyptians were masterful engineers, and their techniques for quarrying and splitting massive stones continue to fascinate us today. One intriguing method they might have employed involves the clever use of water to break apart enormous blocks of stone. This technique likely relied on the expansive force of water as it freezes. The process would begin by carving a line of holes or a long groove along the desired split in the rock. Workers would then fill these openings with water and plug them tightly. As temperatures dropped at night, the water would freeze and expand, exerting tremendous pressure on the surrounding stone. The freeze-thaw cycle, repeated over several days or weeks, would gradually widen existing cracks and create new ones. Eventually, this process would cause the stone to split along the predetermined line. This method takes advantage of the fact that water expands by about 9% when it freezes, generating forces powerful enough to crack even the hardest granite. While this technique would have required patience and careful planning, it offered a relatively low-tech solution to a monumental challenge. The ancient Egyptians likely combined this method with other techniques, such as using wooden wedges and metal tools to efficiently quarry and shape the massive stones used in their iconic structures. Ancient civilizations faced immense challenges when moving massive stone blocks for their monumental constructions. Wooden rollers and sleds played crucial roles in this arduous process, serving as ingenious solutions to transport these colossal stones across vast distances. Wooden rollers functioned as a primitive but effective wheel system. Craftsmen would cut logs into cylindrical shapes, placing them beneath the stone blocks. As the block moved forward, workers continuously repositioned the rollers from the back to the front, creating a rolling platform that significantly reduced friction. This method allowed for the movement of incredibly heavy stones with relatively less human effort. Sleds, on the other hand, were flat wooden structures designed to distribute the weight of the stone block over a larger surface area. These sleds were often pulled by teams of workers or animals over smoother surfaces. In some cases, ancient builders would wet the ground in front of the sled, creating a slippery mud that further eased the sled's movement. This technique was particularly useful when transporting stones uphill or over uneven terrain. The combination of rollers and sleds provided ancient builders with a versatile system for stone transportation. Rollers excelled on flat, firm ground, while sleds proved advantageous on softer or more challenging surfaces. This dual approach enabled the construction of awe-inspiring structures like the Egyptian pyramids and massive stone temples, showcasing the ingenuity of our ancestors in overcoming seemingly insurmountable engineering challenges. Ancient Egyptians were master builders who developed ingenious techniques to construct their monumental structures. One method they likely employed was the use of counterweight systems. These systems allowed them to move and lift massive stone blocks with greater efficiency than manpower alone. The principle behind counterweight systems is simple, yet effective. By using a weight on one side of a lever or pulley, the Egyptians could reduce the force needed to lift heavy objects on the other side. This technique was particularly useful when raising large stone blocks to build pyramids and temples. Evidence suggests that the Egyptians may have used large wooden beams as levers, with stone counterweights attached to one end. As workers pushed down on the longer end of the lever, the shorter end would lift the heavy stone block. They could then gradually move the fulcrum point, inching the stone upwards. Another possible application of counterweights was in the construction of ramps. By using counterweighted sleds, the Egyptians could more easily transport heavy stones up inclined surfaces. This method would have significantly reduced the manpower required to move massive blocks of limestone and granite used in their grand structures. Archaeological findings and modern analysis have revealed compelling evidence for the use of sophisticated surveying techniques in ancient Egyptian pyramid construction. The remarkable precision in the alignment and proportions of the pyramids points to a level of engineering prowess that surpasses simple tools and methods. One key piece of evidence is the near-perfect square base of the Great Pyramid of Giza. Its sides differ by only a few centimeters over a length of more than 230 meters, an accuracy that would be challenging even with modern equipment. This suggests the use of advanced measuring and surveying tools to achieve such precision. Furthermore, the exact cardinal orientation of the pyramid sides indicates a deep understanding of celestial navigation and the ability to make extremely accurate astronomical observations. Researchers have proposed that the ancient Egyptians might have used a tool similar to a plumb bob, along with sighting poles and stretching of rope, to create precise right angles and maintain straight lines over long distances. The implementation of sophisticated leveling techniques is another indicator of advanced surveying. The base of the Great Pyramid is astonishingly flat, with a maximum deviation of only 2 centimeters across its entire foundation. This level of precision suggests the use of water-filled trenches or other ingenious methods to ensure a perfectly level starting point for construction. The ancient Egyptians were ingenious engineers who likely harnessed the power of water in various aspects of their construction projects. While direct evidence is limited, archaeological findings and historical records suggest several potential applications of hydraulic power. One possible use was in the transportation of massive stone blocks. By creating a network of canals, the Egyptians could have used the annual flooding of the Nile to their advantage. They may have floated heavy stones on barges, moving them closer to construction sites with far less effort than overland transport would require. Hydraulic power might also have been employed in lifting mechanisms. The Egyptians could have used water-filled counterweights in pulley systems to help raise large stones. As water was added to or removed from containers, the weight could be precisely controlled, allowing for careful manipulation of heavy objects. There is also speculation that the Egyptians used water power to soften the ground at construction sites. By flooding an area and then draining it, they could have made the earth more pliable, simplifying the process of digging foundations or creating level surfaces for building. This technique, combined with their advanced knowledge of geometry and surveying, would have greatly aided in the precision of their monumental structures. Ancient Egyptian pyramid construction has long fascinated researchers, with the question of how these massive structures were built using primitive tools remaining a subject of debate. One intriguing theory suggests that the ancient Egyptians may have used a form of concrete in their construction process rather than relying solely on quarried limestone blocks. This theory proposes that the Egyptians created a limestone-based concrete mixture, which they could pour into wooden molds to form blocks on site. Proponents argue that this method would have made it easier to transport materials and construct the pyramids with greater precision. They point to the presence of air bubbles and other irregularities in some pyramid stones as evidence of this casting technique. However, this concrete theory remains controversial among Egyptologists and archaeologists. Many experts maintain that the pyramids were built using traditional methods of quarrying, transporting, and stacking limestone blocks. They argue that tool marks and other evidence support the conventional understanding of pyramid construction. While the debate continues, ongoing research into the composition and structure of pyramid stones may provide more definitive answers about the methods used by ancient Egyptians to create these enduring monuments. The possibility of ancient concrete use in pyramid construction highlights the ingenuity and technological capabilities of early civilizations, challenging our understanding of their engineering prowess. Advanced knowledge of acoustics could have played a surprising role in the construction of ancient pyramids. Sound waves behave in predictable ways, reflecting off surfaces and creating resonance patterns. Ancient builders might have used these principles to their advantage during the massive undertaking of pyramid construction. One theory suggests that acoustic techniques could have been employed to check the precision of pyramid angles and alignment. By producing specific tones at key points, builders may have listened for particular resonances or echoes that indicated correct positioning. This method could have helped ensure the structure maintained its intended shape as it rose to great heights. Acoustic knowledge might also have assisted in the transportation of enormous stone blocks. Some researchers propose that carefully coordinated chants or rhythmic sounds could have reduced friction, making it easier to move heavy objects across sand or ramps. While this idea remains speculative, it highlights the potential for ingenious solutions in ancient engineering. Furthermore, acoustics might have played a role in communication during construction. In the noisy environment of a building site, understanding how sound travels and using specific tones or rhythms could have allowed workers to relay messages effectively across long distances, coordinating their efforts with greater efficiency. The workers who built the ancient Egyptian pyramids were not slaves, as was once widely believed. Recent archaeological evidence reveals that they were skilled Egyptian laborers who took great pride in their work. These builders came from poor families across Egypt, but they were respected for their craftsmanship and given honored burials near the sacred pyramids they constructed. The workforce consisted of a permanent crew of skilled artisans who worked year-round. During the annual Nile flooding, when farming was impossible, this core group was joined by tens of thousands of temporary workers from across Egypt. These seasonal laborers provided the manpower needed for the massive construction projects. The builders were organized into specialized teams, each with specific roles. Some quarried limestone blocks, others transported the stones, and skilled masons fit the blocks precisely into place. There were also carpenters, metalworkers, and other craftsmen who created tools and structures necessary for the building process. Egyptologists have discovered that these workers were well cared for, receiving medical attention, food, and shelter. The builders were paid in rations of bread and beer, staples of the ancient Egyptian diet. This labor system, combining skilled full-time workers with a seasonal influx of temporary laborers, allowed the ancient Egyptians to build their monumental structures while maintaining a strong agricultural economy. The construction of the pyramids required a highly organized workforce, with skilled artisans and laborers working together under the guidance of experienced project managers. Contrary to popular belief, the pyramids were not built by slaves, but by paid Egyptian workers who were divided into specialized teams. These teams were structured in a hierarchical system, with architects and engineers at the top, overseeing the overall design and construction process. Below them were skilled craftsmen, such as stonemasons and carpenters, who were responsible for cutting and shaping the massive limestone blocks used in the pyramid's construction. The bulk of the workforce consisted of unskilled laborers who transported materials, operated simple machinery, and performed other physically demanding tasks. These workers were often farmers who worked on the pyramids during the annual Nile flood, when their fields were submerged and unworkable. To ensure efficiency, the workers were organized into crews and given specific tasks. They worked in shifts, with groups rotating between the construction site and nearby worker villages. This system allowed for continuous progress while providing necessary rest periods for the laborers. The entire operation was carefully planned and executed, demonstrating the ancient Egyptians' remarkable organizational and engineering skills. Contrary to popular belief, the workers who built the ancient Egyptian pyramids were not slaves, but skilled laborers and craftsmen. Archaeological evidence from worker villages near the Giza Plateau has revealed fascinating details about their living conditions. Excavations have uncovered well-planned settlements with organized housing, communal dining halls, and even healthcare facilities. The workers' dwellings were simple yet functional, arranged in neat rows and built from mud bricks. These homes provided shelter from the harsh desert climate and were equipped with basic amenities. Archaeologists have discovered remnants of beds, storage containers, and cooking areas within these structures, indicating a level of comfort for the workers. Perhaps most intriguing are the animal bones found in the workers' trash heaps. Analysis of these remains shows that the pyramid builders had access to high-quality meat, including beef, which was typically reserved for the elite in ancient Egyptian society. This suggests that the workers were well fed and their diet was carefully planned to maintain their strength and health. Evidence of medical care has also been unearthed, including healed fractures and signs of surgeries performed on some workers. This indicates the presence of skilled physicians and a level of healthcare provision that was uncommon for common laborers in the ancient world. These findings paint a picture of pyramid workers as valued members of society, whose well-being was prioritized to ensure the successful completion of these monumental projects. The construction of the ancient Egyptian pyramids involved a complex system of labor and compensation that differed from modern employment practices. Contrary to popular belief, the pyramids were not built by slaves, but by a combination of skilled craftsmen and farmers who worked during the annual Nile flood season when their fields were submerged. These workers were compensated through a system of corvée labor, where they provided service to the state for a certain period each year. In return, they received food, shelter, and other provisions during their time on the construction site. Archaeological evidence from worker villages near the pyramids suggests that laborers were given a diet rich in protein, including beef, fish, and beer, which was considered a staple of the Egyptian diet. Skilled workers, such as stonecutters, architects, and engineers, likely received additional compensation in the form of exemption from other state duties or taxes. Some may have been awarded special burial plots near the pyramids, a significant honor in ancient Egyptian society. The opportunity to work on these monumental projects was also seen as a form of service to the pharaoh and the gods, carrying spiritual significance. Recent discoveries have shed light on the organization of labor, revealing a hierarchical structure with different levels of workers and overseers. This system ensured efficient management of the massive workforce required for pyramid construction, with each group receiving compensation appropriate to their skill level and responsibilities. The construction of ancient Egyptian pyramids demanded a wide array of specialized skills from workers across different levels of society. At the foundation were the skilled stonemasons, who possessed an intimate knowledge of various types of rock and the techniques required to cut and shape them with precision. These artisans used copper chisels and bronze saws to carefully craft the massive limestone blocks that formed the pyramid's core. Surveyors and engineers played a crucial role in the planning and execution of these monumental structures. They employed sophisticated mathematical knowledge and astronomical observations to ensure the pyramid's perfect square base and precise alignment with the cardinal directions. These experts also designed and implemented the intricate internal chambers and passageways within the pyramid. Transportation specialists devised ingenious methods to move enormous stone blocks from quarries to construction sites. They created sleds, ramps, and lever systems, coordinating large teams of workers to maneuver the heavy materials into place. Equally important were the carpenters who constructed wooden rollers, sleds, and scaffolding essential for the building process. Scribes and project managers kept meticulous records of resources, labor, and progress, ensuring the massive undertaking stayed on track. They coordinated the efforts of thousands of workers, managing food supplies, tool production, and the logistics of this complex, multi-year endeavor. The successful construction of pyramids relied on this diverse array of skills, showcasing the remarkable organizational and technological capabilities of ancient Egyptian civilization. The ancient Egyptians employed a sophisticated system to recruit and train workers for their monumental pyramid-building projects. Contrary to popular belief, these massive structures were not built by slaves, but by a combination of skilled craftsmen and farmers who worked during the annual Nile flood season when their fields were submerged. The pharaohs and their officials organized a rotation system, calling on villages throughout Egypt to send workers for specific periods. This approach ensured a constant supply of labor while allowing individuals to return to their regular lives and duties. The workers were divided into crews and given specific tasks based on their skills and experience. Training was a crucial aspect of the pyramid building process. Experienced craftsmen passed down their knowledge to apprentices, teaching them specialized skills such as stone cutting, transport techniques, and precise measurement methods. This apprenticeship system created a workforce capable of tackling the complex challenges of pyramid construction. The ancient Egyptians also developed innovative tools and techniques to enhance worker efficiency. They used copper chisels, bronze saws, wooden rollers and sleds, ramps and levers to cut, transport, and position the massive stone blocks. These advancements, combined with their organizational skills and labor management, allowed them to complete these awe-inspiring monuments that continue to captivate us thousands of years later. Contrary to popular belief, the ancient Egyptian pyramids were not built by slaves. Recent archaeological evidence and historical research have revealed that the workers who constructed these monumental structures were actually skilled laborers and craftsmen. These workers were free Egyptians who took great pride in their work and were compensated for their efforts. The construction of the pyramids was a massive undertaking that required a large workforce. This workforce consisted of permanent employees and temporary laborers who worked on the project during the annual Nile flood season when farming activities were suspended. These workers were organized into teams and provided with housing, food, and medical care. Excavations near the Giza pyramids have uncovered the remains of worker villages, complete with bakeries, breweries, and copper workshops. These findings suggest that the pyramid builders were well fed and cared for, further supporting the idea that they were not slaves but respected members of society. The misconception about slave labor in pyramid construction likely stems from later Greek and Roman accounts, as well as biblical references to Hebrew slaves in Egypt. However, these accounts are not historically accurate for the time of pyramid building, which occurred much earlier in Egyptian history. The pyramids stand as a testament to the ingenuity, skill, and cooperative effort of ancient Egyptian society rather than as monuments to oppression and forced labor. The seasonal flooding of the Nile played a crucial role in shaping the workforce that built the pyramids of ancient Egypt. During the annual inundation, which typically occurred between June and September, the Nile would overflow its banks, covering the surrounding farmlands with nutrient-rich silt. This natural cycle created a unique work schedule for the ancient Egyptians. When the floodwaters rose, agricultural work became impossible, freeing up a large portion of the population to participate in state-sponsored construction projects, including the building of pyramids. This timing was ideal for the pharaohs, as it provided a massive labor force during a period when farming activities were suspended. The flood season also facilitated the transportation of heavy stone blocks used in pyramid construction. The higher water levels allowed boats to navigate closer to the construction sites, making it easier to move massive limestone and granite blocks from distant quarries. This efficient transportation system was essential for the timely completion of these monumental structures. As the floodwaters receded, many workers would return to their fields, continuing a cycle that balanced the needs of agriculture with the demands of large-scale construction projects. This system ensured that pyramid building could progress without significantly disrupting the vital food production that sustained Egyptian society. Recent archaeological discoveries have shed new light on the diet and health of ancient Egyptian pyramid workers. Contrary to popular belief, these laborers were not slaves, but skilled workers who received good nutrition and medical care. Excavations at worker villages near the Giza pyramids have uncovered animal bones and plant remains that reveal a protein-rich diet including beef, sheep, goat, and fish. This diet was supplemented with bread, beer, and a variety of fruits and vegetables. Analysis of human remains from nearby cemeteries provides further insights into worker health. Many skeletons show signs of healed fractures and injuries, indicating access to medical treatment. Surprisingly, examinations of worker teeth reveal relatively low rates of dental decay, suggesting a diet lower in sugars and carbohydrates than previously thought. However, there is evidence of wear on teeth and joints, consistent with the physical demands of pyramid construction. Hieroglyphic records describe rations provided to workers, corroborating the archaeological evidence. These texts mention daily allowances of bread, beer, and vegetables, with meat distributed on special occasions. The abundance and variety of food remains found at worker sites align with these written accounts, painting a picture of well-fed laborers rather than malnourished slaves. Despite the demanding nature of their work, the overall health of pyramid builders appears to have been better than that of the average ancient Egyptian. This evidence challenges long-held assumptions about the treatment of workers in ancient Egypt and provides a more nuanced understanding of the social structure and labor practices during the construction of these monumental structures. Contrary to popular belief, the workers who built the pyramids were not slaves, but respected craftsmen and laborers. Recent archaeological evidence has shed light on their living conditions and social status, revealing a more nuanced picture of ancient Egyptian society. Pyramid workers were often skilled artisans, engineers, and builders who took pride in their work. They received payment in the form of food, housing, and other necessities, and were even provided with medical care. The Egyptian government organized these workers into crews and teams, with each group responsible for specific tasks. Many of the workers were farmers who participated in pyramid construction during the annual Nile flood season when agricultural work was impossible. This arrangement allowed them to earn additional income and contribute to a project of immense national and religious significance. The opportunity to work on the pyramids was seen as an honor and a way to serve the pharaoh and the gods. Excavations near the Giza pyramids have uncovered worker villages with evidence of a varied diet, including high-quality meat, suggesting that these laborers were well fed and cared for. While their status was not equal to that of nobles or priests, pyramid workers enjoyed a higher standing than many other ancient Egyptians, reflecting the importance of their role in creating these monumental structures. The Great Pyramids of Egypt have long captivated our imagination, and while most archaeologists agree they were built as tombs for the pharaohs, some alternative theories have emerged over the years. One intriguing proposal suggests the pyramids were actually enormous water pumps designed to irrigate the surrounding desert. Proponents of this idea argue that the internal chambers and passages could have been used to create a hydraulic pulse that lifted water from the Nile. Another unconventional theory posits that the pyramids were power plants, generating electricity through a combination of flowing water and vibrations. This concept, though lacking scientific evidence, speculates that the ancient Egyptians had advanced knowledge of energy production that has since been lost to time. Some researchers have proposed that the pyramids served as astronomical observatories, their precise alignment with celestial bodies allowing for accurate timekeeping and prediction of celestial events. This theory suggests the ancient Egyptians possessed a deeper understanding of the cosmos than previously thought. Perhaps one of the most far-fetched ideas is that the pyramids were built by extraterrestrial visitors or with their advanced technology. While this notion has captured public imagination, it is not supported by archaeological evidence and is dismissed by mainstream scientists. The idea that the pyramids of ancient Egypt functioned as power plants is a speculative theory not supported by scientific evidence. Archaeologists and historians agree that the pyramids were primarily built as monumental tombs for the pharaohs, serving as gateways to the afterlife in ancient Egyptian religious beliefs. However, some alternative theories suggest the pyramids could have had additional purposes. One such idea proposes that the internal structure of the Great Pyramid of Giza, with its network of chambers and shafts, might have been designed to harness energy. Proponents of this theory point to the pyramid's ability to concentrate electromagnetic energy in its chambers. They argue that the limestone blocks used in construction, along with the underground water channels, could have been used to generate and store electrical power. Another aspect of this theory focuses on the possibility that ancient Egyptians used advanced knowledge of acoustics within the pyramids. The Grand Gallery and King's Chamber in the Great Pyramid have unique acoustic properties that some believe could have been used for sound amplification or even to create infrasound waves. While these ideas are intriguing, they remain highly controversial and lack substantial evidence. The vast majority of experts maintain that the primary function of the pyramids was funerary and symbolic, reflecting the ancient Egyptians' complex beliefs about the afterlife and the divine nature of their rulers. The idea that ancient Egyptian pyramids were used for initiatory rites is an intriguing theory, though it remains speculative and not widely accepted by mainstream Egyptologists. However, some researchers have pointed to certain architectural features and archaeological findings that they believe support this hypothesis. One piece of evidence often cited is the complex internal structure of pyramids, particularly the Great Pyramid of Giza. The intricate network of passages, chambers, and shafts within the pyramid could be interpreted as a symbolic journey for initiates. The Grand Gallery, with its imposing height and length, might have served as a dramatic setting for ceremonial processions or rituals. Another aspect that proponents of this theory highlight is the presence of sarcophagi in pyramid chambers. While traditionally viewed as burial containers, some argue that these stone boxes could have been used in symbolic death and rebirth rituals, common themes in many ancient mystery schools and initiation ceremonies. Hieroglyphic texts found in some pyramids, known as the pyramid texts, describe spiritual transformations and journeys to the afterlife. Some researchers interpret these not just as funerary instructions, but as guides for living initiates undergoing spiritual trials. However, it is important to note that the primary purpose of pyramids as tombs for pharaohs remains the most widely accepted interpretation among scholars. The ancient Egyptian pyramids, while primarily known as monumental tombs, could have indeed served as centers for scientific research in several ways. Their precise construction required advanced knowledge of mathematics, astronomy, and engineering, suggesting they were hubs of intellectual activity. Astronomers likely used the pyramids as observation points to study the night sky. The structure's alignment with cardinal directions and certain stars indicates a deep understanding of celestial movements. This knowledge was crucial for creating accurate calendars and predicting important events like the annual flooding of the Nile. The pyramids could have also been used as laboratories for studying geometry and physics. Their construction involved complex calculations and problem-solving, potentially leading to advancements in these fields. The precise cutting and transportation of massive stone blocks might have spurred innovations in tools and construction techniques. Furthermore, the pyramids could have served as centers for medical research. The mummification process, closely associated with pyramid burials, required extensive knowledge of human anatomy and preservation techniques. This could have led to advancements in medicine and chemistry, as priests and embalmers experimented with various substances and methods to perfect the art of mummification. Some fringe theories suggest the ancient Egyptian pyramids could have been used for weather control, though these ideas lack scientific support. One such concept proposes that the pyramid's shape and construction materials might have allowed them to harness atmospheric electricity. Proponents claim the limestone blocks could accumulate electric charge, potentially influencing local weather patterns. Another speculative theory posits that the pyramid's precise alignment with cardinal directions might have created a resonance effect with Earth's magnetic field, supposedly altering air currents and rainfall. Some enthusiasts even suggest the pyramids could generate a form of scalar waves, hypothetical longitudinal waves, that could allegedly modify weather systems. It is important to note that mainstream archaeologists and scientists reject these theories. The consensus among experts is that the pyramids were built as monumental tombs for pharaohs, not as weather manipulation devices. These alternative ideas often arise from misinterpretations of the pyramid's complex architecture and the advanced engineering skills of ancient Egyptians. While these theories capture the imagination, they highlight the human tendency to seek extraordinary explanations for impressive achievements of the past. The real marvel of the pyramids lies in the ingenuity and determination of their builders, who created enduring monuments with the tools and knowledge available to them thousands of years ago. The ancient Egyptian pyramids, while primarily serving as monumental tombs for pharaohs, have sparked numerous theories about potential secondary functions. Some researchers have proposed that these massive structures might have played a role in long-distance communication, though it is important to note that this idea remains speculative and is not widely accepted by mainstream archaeologists. One theory suggests that the smooth, polished limestone surfaces of the pyramids could have been used to reflect sunlight over great distances. This reflection, visible from afar, might have served as a beacon or signal. The Great Pyramid of Giza, when intact, would have been particularly effective for this purpose due to its height and highly reflective surface. Another hypothesis proposes that the internal structure of the pyramids, with their complex system of chambers and passages, could have been designed to amplify and transmit sound waves. Some researchers have suggested that low-frequency vibrations generated within the pyramid could potentially travel long distances through the ground, possibly allowing for a form of primitive long-range communication. While these ideas are intriguing, it is crucial to approach them with skepticism. The primary purpose of the pyramids as royal tombs is well established, and there is currently no conclusive evidence to support their use as intentional communication devices. Nevertheless, these theories continue to fuel fascination with these ancient wonders and drive ongoing research into their construction and potential uses. The concept of pyramids as repositories of ancient knowledge has intrigued researchers and enthusiasts for centuries. While there is no definitive proof of this idea, several lines of evidence have fueled speculation and debate. One compelling aspect is the precise astronomical alignment of many pyramids, particularly those in Egypt. The Great Pyramid of Giza, for instance, is oriented with remarkable accuracy to the cardinal points of the compass. This suggests a sophisticated understanding of celestial movements and geometry, possibly indicating that the builders encoded astronomical knowledge into the structures themselves. The internal layout of some pyramids, with complex systems of chambers and passageways, has led some to propose that these structures were designed to preserve information. The presence of intricate hieroglyphs and symbols within many pyramids further supports the notion that they were meant to convey messages or store knowledge for future generations. Additionally, the mathematical precision evident in pyramid construction, such as the golden ratio found in some of their proportions, has been interpreted by some researchers as evidence of advanced scientific and mathematical understanding. While mainstream archaeology often views these features as primarily related to religious and funerary purposes, the debate about pyramids as knowledge repositories continues to captivate the imagination of many. The ancient Egyptians were skilled astronomers, and the pyramids may have played a crucial role in their celestial observations. The Great Pyramid of Giza, in particular, demonstrates remarkable astronomical alignments. Its sides are precisely oriented to the 4 cardinal directions, with an accuracy that speaks to the builder's advanced understanding of celestial movements. The pyramid's design allowed for specific astronomical events to be observed and recorded. The descending passage in the Great Pyramid points directly to the North Celestial Pole, which at the time of its construction would have aligned with the star Thuban in the constellation Draco. This alignment could have been used to track the passage of time and the changing seasons. Moreover, the pyramid's smooth, angled sides could have served as giant sundials, casting shadows that moved predictably throughout the year. By observing these shadows, ancient astronomers could have determined solstices, equinoxes, and other important celestial events with remarkable precision. The pyramids may also have functioned as platforms for nighttime observations. From their elevated summits, astronomers would have had an unobstructed view of the night sky, free from the interference of ground-level obstacles. This vantage point would have been invaluable for tracking the movements of stars, planets, and other celestial bodies, contributing to the Egyptians' sophisticated understanding of astronomy and its practical applications in agriculture and religious ceremonies. While the ancient Egyptians primarily built pyramids as tombs for pharaohs and their consorts, some alternative theories propose different purposes for these monumental structures. One such theory suggests that the pyramids were constructed as a form of protection against natural disasters, particularly flooding from the Nile River. Proponents of this idea argue that the pyramid's massive stone construction and elevated position on the Giza Plateau could have served as a refuge during severe flooding events. They claim that the ancient Egyptians might have used these structures as emergency shelters, storing food and supplies within the internal chambers and galleries. Another related theory posits that the pyramids were designed to stabilize the Earth's crust and mitigate the effects of earthquakes. This concept, though not supported by mainstream archaeology, proposes that the pyramid's shape and precise positioning could have helped disperse seismic energy and reduce ground movement during tremors. It's important to note that these theories lack substantial evidence and are not accepted by most Egyptologists and archaeologists. The overwhelming consensus among experts is that the pyramids were primarily built as elaborate tombs, reflecting the ancient Egyptians' complex beliefs about the afterlife and the divine nature of their pharaohs. Ancient Egyptian beliefs intertwined the physical and spiritual realms, with the pyramids serving as monumental gateways between worlds. These massive structures were designed to facilitate the pharaoh's journey to the afterlife, but they may have also played a role in spiritual practices for the living. The precise geometry and alignment of the pyramids suggest they were constructed with cosmic significance in mind. The Great Pyramid of Giza, for instance, aligns almost perfectly with the cardinal directions. This orientation could have been used in rituals to connect with celestial energies or divine forces. Some researchers propose that the internal chambers and passageways of pyramids were designed for more than just burial purposes. These spaces might have been used for meditation, initiation rites, or other spiritual ceremonies. The unique acoustics within the pyramids, which produce specific resonant frequencies, could have enhanced these experiences, potentially inducing altered states of consciousness. While these ideas remain speculative, they highlight the enduring mystery and allure of the pyramids. The ancient Egyptians' sophisticated understanding of architecture, astronomy, and spirituality continues to captivate our imagination. inviting us to consider the profound connections between the physical world and the realm of spiritual enlightenment. Researchers have detected some intriguing electromagnetic anomalies around the ancient Egyptian pyramids, particularly the Great Pyramid of Giza. These phenomena have sparked curiosity and debate among scientists and enthusiasts alike. One of the most notable observations is the apparent concentration of electromagnetic energy within the pyramid's internal chambers. Studies have shown that the pyramid seems to focus electromagnetic waves into its central chambers, creating pockets of higher energy. This focusing effect is particularly strong for radio wave frequencies. Another interesting phenomenon is the reported formation of an energy vortex above the pyramid's apex. Some researchers claim to have measured an upward flowing energy field extending from the top of the pyramid. This field allegedly intensifies during certain astronomical alignments and specific times of the day. Additionally, there have been reports of unusual static electricity buildup around the pyramid, especially near its summit. Some visitors and investigators have described experiencing tingling sensations or seeing small electrical discharges when touching the structure under certain atmospheric conditions. While these claims are intriguing, it's important to note that more rigorous scientific investigation is needed to fully understand and verify these electromagnetic phenomena associated with the pyramids. The pyramids, specifically their shape and structure, have been the subject of various scientific studies regarding their potential effects on organic matter and plant growth. Research has shown that pyramid-shaped structures can create unique energy fields that may influence the surrounding environment. Some experiments have demonstrated that seeds placed inside small-scale pyramid models tend to germinate faster and produce healthier plants compared to those grown in standard conditions. This phenomenon is believed to be related to the concentration of electromagnetic energy within the pyramid shape, which might stimulate plant growth and development. Regarding the preservation of organic matter, studies have found that food items placed inside pyramid structures tend to dehydrate rather than decay. This effect is particularly noticeable with fruits and vegetables, which often dry out and maintain their form for extended periods. Scientists attribute this to the pyramid's ability to create a microclimate that reduces moisture and inhibits the growth of bacteria and fungi responsible for decomposition. While these findings are intriguing, it is important to note that the scientific community remains divided on the exact mechanisms behind these effects. More research is needed to fully understand how pyramid shapes influence biological processes and whether these effects can be consistently replicated on a larger scale. The pyramids of ancient Egypt continue to intrigue scientists with their mysterious acoustic properties. One of the most fascinating phenomena observed is the way sound behaves inside the king's chamber of the Great Pyramid of Giza. Researchers have discovered that this room possesses unique resonant frequencies, particularly around 20 Hz, which falls just below the range of human hearing. This low-frequency resonance creates a sense of awe and even physical sensation for those inside the chamber. Another unexplained acoustic feature is the pyramid's ability to focus sound waves. Some studies suggest that the internal structure of the pyramid can amplify and concentrate sound at specific points within the monument. This effect is particularly noticeable in certain chambers and corridors where whispers can be heard with remarkable clarity across considerable distances. The external shape of the pyramid also influences sound in puzzling ways. Experiments have shown that the pyramid can reflect and scatter acoustic waves in patterns that are not fully understood. Some researchers propose that these properties might have been intentionally designed by the ancient Egyptians, possibly for ceremonial or communication purposes. These acoustic mysteries extend beyond the Great Pyramid. Similar phenomena have been observed in other pyramids and ancient structures around the world, suggesting a possible shared knowledge of acoustic engineering among ancient civilizations. As scientists continue to study these properties, they hope to unravel the secrets of pyramid construction and potentially uncover lost ancient wisdom about the manipulation of sound. Cosmic radiation constantly bombards our planet, showering Earth with high-energy particles from space. These particles originate from various cosmic sources, including distant stars, supernovae, and even other galaxies. As they travel through the atmosphere and reach the ground, they interact with everything in their path, including ancient structures like the pyramids of Egypt. The massive stone blocks that make up the pyramids act as a shield against cosmic radiation, absorbing and scattering the incoming particles. This interaction creates a unique pattern of radiation within and around the pyramids. Scientists have used specialized detectors to measure these patterns, revealing fascinating insights about the internal structure of these ancient monuments. One intriguing discovery is that the cosmic radiation passing through the pyramids can be used to create a type of X-ray image of their interior. This technique, known as muon tomography, utilizes muons, which are subatomic particles created when cosmic rays collide with atoms in the Earth's atmosphere. By tracking how these muons pass through the pyramid, researchers can identify hidden chambers or voids within the structure without damaging the ancient stonework. The study of cosmic radiation interacting with the pyramids not only provides valuable information about these ancient wonders, but also contributes to our understanding of particle physics and the development of new imaging technologies. This intersection of ancient architecture and modern science demonstrates how structures built thousands of years ago continue to play a role in advancing our knowledge of the cosmos. Scientists have detected several intriguing energy phenomena associated with the pyramids of Egypt, sparking both fascination and debate in the scientific community. One of the most notable discoveries is the presence of electromagnetic energy concentrations at the apex of the Great Pyramid of Giza. Researchers have found that this ancient structure can focus electromagnetic energy in its internal chambers and underneath its base. These findings suggest that the pyramid's shape and materials might create a natural concentrator for electromagnetic waves. Some studies have reported that the energy fields within the pyramid can affect the decay rate of certain materials and potentially influence biological processes. However, these claims remain controversial and require further investigation. Another interesting observation is the detection of infrared radiation at specific points on the pyramid's surface. Thermal imaging has revealed hotspots that cannot be easily explained by conventional heat transfer mechanisms. Some researchers propose that these anomalies might be related to unknown properties of the limestone blocks used in construction or hidden internal structures. Additionally, ultrasound scans have detected unusual vibrations and resonances within the pyramid, leading to speculation about potential energy-focusing properties of its internal chambers. While these findings are intriguing, it is important to note that many of these observations require additional research and peer review to fully understand their significance and implications for our understanding of ancient Egyptian engineering and potential applications in modern technology. The ancient Egyptian pyramids, colossal structures built thousands of years ago, have a surprising influence on the movement of underground water. These massive monuments interact with the subterranean environment in ways that were likely unforeseen by their builders. The sheer weight of the pyramids compresses the ground beneath them, altering the density and permeability of the underlying soil and rock layers. This compression creates areas of increased resistance to water flow, effectively acting as a barrier that redirects the natural movement of underground water. Furthermore, the extensive foundation systems of the pyramids, which often extend deep into the earth, can intersect with underground aquifers and water channels. These foundations can act as artificial conduits, guiding water along new paths and potentially changing the local hydrology. The alterations in underground water flow caused by the pyramids can have far-reaching effects on the surrounding landscape. Changes in water availability can impact local vegetation patterns, soil stability, and even the long-term preservation of the pyramids themselves. This interaction between ancient architecture and natural hydrological systems continues to fascinate scientists and engineers, highlighting the complex and often unexpected ways human structures can shape their environment over millennia. The Giza Plateau, home to the iconic Great Pyramids of Egypt, has been the subject of intriguing meteorological observations in recent years. Scientists have noted a peculiar microclimate forming around the ancient structures, characterized by localized temperature inversions and unexpected air currents. One of the most striking phenomena is the formation of small, localized dust devils that seem to occur more frequently near the base of the Great Pyramid of Khufu. These swirling vortices of air and sand appear to be influenced by the unique geometry of the pyramid, which creates distinct patterns of airflow and temperature gradients. Researchers have also documented unusually rapid temperature fluctuations in the immediate vicinity of the pyramids, with temperature differences of up to 5 degrees Celsius observed between the pyramid's base and its surrounding area. This temperature anomaly is thought to be caused by the pyramid's massive stone structures absorbing and radiating heat differently than the surrounding desert landscape. Furthermore, there have been reports of increased electrical activity in the air around the Giza Plateau, particularly during the hot, dry Khamsin winds that blow through the region. Some scientists speculate that the combination of the pyramid's shape, the atmospheric conditions, and the mineral content of the limestone blocks may contribute to the generation of localized electrical fields, though more research is needed to fully understand this phenomenon. The ancient Egyptian pyramids have stood the test of time, enduring for thousands of years while other structures have crumbled. This remarkable longevity is due to several factors that contribute to their resilience against erosion and decay. The pyramid's durability starts with their construction materials. Built primarily from limestone blocks, these structures benefit from the natural properties of this sedimentary rock. Limestone is composed of calcium carbonate, which forms a protective layer when exposed to air and water. This process, known as case hardening, actually strengthens the outer surface of the stone over time. The design of the pyramids also plays a crucial role in their preservation. Their broad base and tapered shape distribute weight evenly, minimizing stress on individual blocks. This architectural feature reduces the likelihood of structural weakening and collapse. Additionally, the smooth, angled sides of the pyramids allow rainwater to flow off quickly, limiting water damage and erosion. The arid climate of Egypt has been another ally in the pyramid's longevity. With minimal rainfall and low humidity, the environment has been less conducive to weathering processes that typically affect stone structures. The absence of freeze-thaw cycles, which can cause significant damage in colder climates, has further contributed to the pyramid's preservation. These combined factors have allowed the pyramids to maintain their iconic shape and structure for millennia, seemingly defying normal rates of decay. Throughout history, various unexplained visual phenomena have been reported around the pyramids of Egypt, capturing the imagination of both locals and visitors. One intriguing occurrence is the sighting of strange lights hovering above or near the pyramids, often described as orbs or glowing spheres that move in unconventional patterns. These lights, which defy explanation by conventional means, have been witnessed by numerous observers and occasionally captured on camera. Another puzzling phenomenon is the appearance of mysterious mists or fogs that seem to materialize around the base of the pyramids, even on clear days. These vaporous formations sometimes take on unusual shapes or exhibit behavior that doesn't align with normal atmospheric conditions, leading some to speculate about their origin and nature. Some visitors have reported seeing brief glimpses of apparitions or shadowy figures moving in and around the pyramid complexes, particularly during nighttime hours. While skeptics attribute these sightings to tricks of light and shadow or overactive imaginations, others believe they may be connected to the ancient Egyptian belief in the afterlife and the spiritual significance of the pyramids. Unusual optical effects have also been observed, such as mirages that appear to show structures or landscapes that aren't actually present. These visual anomalies have fueled theories about hidden chambers or undiscovered features of the pyramids, adding to the ongoing mystery surrounding these ancient monuments. Time dilation near the pyramids is a fascinating phenomenon that challenges our understanding of physics. The immense mass of these ancient structures creates a localized gravitational field, subtly warping space-time in their vicinity. This effect, while incredibly small, has been measured using highly sensitive atomic clocks. Scientists have detected that time moves slightly faster at the top of the pyramids compared to their base. The difference is minuscule, amounting to mere fractions of a second over thousands of years, but it is measurable. This time, dilation is consistent with Einstein's theory of general relativity, which predicts that gravity affects the flow of time. Interestingly, the pyramid's shape may enhance this effect. The tapering structure could potentially focus gravitational waves, intensifying the time dilation at certain points. However, this aspect remains theoretical and requires further study. While the time dilation effect of the pyramids is too small to impact our daily lives, it serves as a remarkable demonstration of the profound interconnectedness of mass, gravity, and time in our universe. It reminds us that even ancient monuments can reveal new insights into the fundamental nature of reality. Pyramid construction was a remarkably widespread phenomenon across numerous ancient cultures, spanning multiple continents and time periods. This architectural form emerged independently in various parts of the world, showcasing a fascinating convergence of human ingenuity and cultural expression. In Africa, the most famous pyramids are those of ancient Egypt, built as monumental tombs for pharaohs. However, pyramid building extended beyond Egypt to other parts of the continent. The ancient kingdom of Kush, located in what is now Sudan, constructed its own distinctive steep-sided pyramids, continuing this tradition long after it had ceased in Egypt. Crossing the Atlantic, we find an abundance of pyramid structures in the Americas. The Mayans and Aztecs of Mesoamerica built impressive step pyramids as centerpieces of their cities, serving as temples and ceremonial spaces. Further south, in Peru, the Moche culture created adobe brick pyramid temples known as huacas. Even in North America, ancient Mississippian cultures constructed large earthen mounds, some of which took on pyramid-like forms. In Asia, pyramid building also took hold. China's first emperor, Qin Shi Huang, was entombed in a massive earthen pyramid mausoleum. In Indonesia, the massive stepped pyramid of Borobudur stands as a testament to ancient Buddhist architecture. This global distribution of pyramids, each adapted to local materials, beliefs, and purposes, highlights a shared human drive to create monumental structures that reach toward the sky. Pyramids, those iconic structures that have captured human imagination for millennia, are not unique to Egypt. Similar structures have been discovered across the globe, from the Americas to Asia, revealing fascinating parallels in human engineering and cultural practices. One striking similarity is the basic shape itself. Pyramids worldwide generally feature a broad base that tapers to a point or a flat top, creating a stable and visually impressive structure. This design is not merely aesthetic, but serves practical purposes, allowing for height while maintaining structural integrity. The use of pyramids as burial monuments or religious sites is another common thread. In Egypt, pyramids housed pharaohs and their possessions for the afterlife. Similarly, in Mesoamerica, pyramids often contained tombs of rulers or served as temples for religious ceremonies. This connection between pyramids and the sacred appears to be a recurring theme across cultures. Construction techniques also show surprising similarities. Many pyramids, regardless of location, were built using a stepped or layered approach, with smaller stones filled in to create smooth outer surfaces. The precise stone cutting and fitting methods used in Egypt find echoes in the techniques employed by the Inca in South America, suggesting that ancient builders worldwide developed comparable solutions to similar architectural challenges. Step pyramids in Mesoamerica and the smooth-sided pyramids of Egypt represent distinct architectural styles that reflect the unique cultures and purposes of their builders. Mesoamerican step pyramids, found in ancient cities like Teotihuacan and Chichen Itza, feature a series of stacked platforms that decrease in size as they ascend. These structures often had steep staircases leading to temples at their summits, serving as both religious centers and displays of political power. The Mesoamerican pyramids were typically built over long periods, with new layers added by successive rulers to increase their height and grandeur. In contrast, Egyptian pyramids evolved from earlier step pyramid designs to the iconic smooth-sided structures we associate with ancient Egypt today. The most famous examples, such as the Great Pyramid of Giza, were built as tombs for pharaohs. Their smooth, angled sides were achieved by using carefully cut limestone blocks, creating a more uniform appearance than their Mesoamerican counterparts. While both types of pyramids served as monumental structures, their functions differed. Mesoamerican pyramids were primarily used for religious ceremonies and as platforms for temples, whereas Egyptian pyramids were elaborate burial chambers designed to protect the pharaoh's body and possessions for the afterlife. These architectural differences highlight the distinct cultural and religious beliefs of these two great ancient civilizations. Ancient pyramids found on different continents share intriguing similarities that have led some researchers to speculate about possible connections between their builders. In Egypt, Mexico, and Peru, we find massive stone structures with precise astronomical alignments and sophisticated engineering techniques. These parallels have sparked debate among archaeologists and historians. One striking commonality is the use of advanced mathematical concepts in pyramid design. Both Egyptian and Mesoamerican pyramids incorporate the golden ratio, a proportion found throughout nature and considered aesthetically pleasing. This mathematical precision suggests a deep understanding of geometry and engineering principles among ancient builders separated by vast distances. Another shared feature is the alignment of pyramids with celestial bodies. The Great Pyramid of Giza aligns with true north with remarkable accuracy, while pyramids in Teotihuacan, Mexico, align with the Pleiades star cluster. This astronomical knowledge implies sophisticated observational skills and a shared interest in connecting earthly structures with the cosmos. However, it's important to note that many experts attribute these similarities to independent development rather than direct contact. They argue that humans facing similar challenges and inspired by similar natural phenomena might arrive at comparable solutions. The debate continues, with ongoing research and archaeological discoveries providing new insights into the fascinating world of ancient pyramid builders. Ancient civilizations across the globe constructed pyramids with remarkable precision, often aligning these monumental structures with celestial bodies and astronomical events. In Egypt, the Great Pyramid of Giza is oriented with astonishing accuracy to the cardinal directions, its sides aligning almost perfectly north-south and east-west. This alignment allowed the ancient Egyptians to use the pyramid as a solar calendar, with its shadow patterns marking the solstices and equinoxes. Halfway around the world, the Mayan pyramids in Mesoamerica show similar astronomical connections. The Temple of Kukulkan at Chichen Itza is precisely aligned so that during the spring and autumn equinoxes, the setting sun creates a shadow pattern resembling a serpent descending the pyramid steps. This effect, known as the descent of Kukulkan, demonstrates the Mayans' advanced understanding of celestial mechanics and their ability to incorporate this knowledge into architectural design. In Peru, the Incan site of Machu Picchu features structures aligned with the June solstice sunrise, while in Cambodia, certain temples of Angkor Wat align with the spring equinox. These global examples highlight a universal human fascination with the cosmos and a desire to connect earthly structures with heavenly movements. The precision of these alignments continues to astound modern researchers, raising questions about the advanced astronomical knowledge and engineering capabilities of ancient civilizations. These pyramids serve not only as monuments to human ingenuity, but also as enduring calendars and observatories, linking the terrestrial realm with the cosmic order above. Pyramids, those iconic structures that have captured human imagination for millennia, share several common building techniques across different cultures and continents. One of the most fundamental similarities is the use of a wide, stable base that gradually narrows towards the apex. This design naturally distributes the immense weight of the structure and provides stability that has allowed many pyramids to endure for thousands of years. Stonemasonry forms the core of most pyramid construction techniques. Builders typically used locally sourced stone blocks, carefully cut and fitted together with remarkable precision. In many cases, these blocks were so well matched that mortar was unnecessary, with the weight of the stones themselves holding the structure together. Another common technique involves the use of internal chambers and passageways. While the specific layouts vary, many pyramids incorporate complex internal structures, often aligned with astronomical phenomena or designed for specific ceremonial purposes. These internal spaces required sophisticated engineering to support the weight above them. Stepped construction is another shared feature among many pyramids worldwide. Builders would create a series of levels or tiers, each smaller than the one below, to form the characteristic pyramid shape. In some cases, these steps remained visible, while in others, they were filled in to create smooth sides. This method allowed for easier transport of materials to higher levels during construction and provided a stable framework for the entire structure. Pyramids have served diverse purposes across cultures, reflecting the unique beliefs, values, and societal structures of their builders. In ancient Egypt, pyramids were monumental tombs for pharaohs, designed to protect the ruler's body and possessions for the afterlife. These massive structures symbolized the pharaoh's divine status and ensured their immortality. Mesoamerican cultures, including the Maya and Aztecs, built pyramids as religious centers and places of ritual. These step pyramids often featured temples at their summits where priests performed ceremonies, including human sacrifices, to appease the gods. Unlike their Egyptian counterparts, Mesoamerican pyramids were frequently built over older structures, creating layers of history within a single monument. In ancient Mesopotamia, ziggurat pyramids served as elevated platforms for temples, bringing worshippers closer to the heavens. These structures were considered dwelling places for the gods and played a central role in religious and civic life. The Kushite civilization of ancient Nubia also constructed steep-sided pyramids as royal tombs. Though these were generally smaller than their Egyptian inspirations, some cultures used pyramid-like structures for entirely different purposes. In ancient China, for instance, flat-topped pyramidal mounds were sometimes used as tombs for emperors, while others may have served astronomical functions. The variety of pyramid uses across civilizations demonstrates how this iconic shape has been adapted to suit different cultural needs and beliefs throughout history. Pyramid construction is a fascinating global phenomenon that has intrigued archaeologists and historians for centuries. Several theories attempt to explain why ancient civilizations across different continents built these monumental structures. One prominent theory suggests that pyramids served as tombs for powerful rulers, particularly in ancient Egypt. These massive structures were believed to facilitate the pharaoh's journey to the afterlife and preserve their earthly possessions. Another theory proposes that pyramids were built as a demonstration of political power and social organization. The ability to mobilize large workforces and resources for such massive construction projects showcased the ruler's authority and the society's cohesion. This theory is supported by evidence from various cultures, including the Maya and the ancient Egyptians. Some researchers argue that pyramids had astronomical significance, serving as observatories or calendars. The precise alignment of many pyramids with celestial bodies suggests they might have been used to track important astronomical events or seasons, crucial for agricultural societies. This theory is particularly relevant for pyramids found in Mesoamerica. While these theories offer compelling explanations, it's important to note that pyramid building likely served multiple purposes, varying across different cultures and time periods. The global occurrence of pyramids might also be attributed to the inherent stability and simplicity of the pyramid shape, making it a logical choice for large-scale construction in ancient times. The ancient Egyptian pyramids stand as some of the oldest monumental structures on Earth, with the Great Pyramid of Giza dating back approximately 4,500 years. However, pyramids are not unique to Egypt, and their ages vary significantly across different cultures and regions. In the Americas, the oldest known pyramids are found in Peru, constructed by the Caral civilization around 4,600 years ago, making them roughly contemporary with the earliest Egyptian pyramids. The more famous Mesoamerican pyramids, such as those built by the Maya and Aztecs, are considerably younger, with most dating from 2,500 to 1,000 years ago. Nubian pyramids in modern-day Sudan were built later than their Egyptian counterparts, starting around 2,700 years ago. These structures were influenced by Egyptian architecture, but developed their own distinct style over time. In Asia, pyramid-like structures emerged much later. The stepped pyramid of Borobudur in Indonesia was built around 1,200 years ago, while Chinese tomb pyramids, such as the mausoleum of the first Qin emperor, date back about 2,200 years. These examples illustrate the global spread of pyramid construction, each with its own cultural significance and architectural style, yet none matching the extreme antiquity of the Egyptian monuments. Archaeological evidence points to intriguing similarities between ancient pyramid-building cultures across different continents, hinting at possible knowledge transfer. In Egypt, Mesoamerica, and parts of South America, we find step pyramids constructed with remarkable precision, often aligned with celestial bodies. These structures share common features like precise stone cutting, complex internal chambers, and advanced engineering techniques that seem to defy the supposed technological limitations of their time. One compelling example is the use of corbelled arches in both Egyptian and Mayan pyramids, a sophisticated architectural technique that allows for the creation of stable, hollow spaces within massive stone structures. This shared building method suggests a potential exchange of architectural knowledge across vast distances and time periods. Furthermore, certain mathematical and astronomical concepts appear to be embedded in pyramid designs from different cultures. The incorporation of the golden ratio and specific astronomical alignments in structures separated by thousands of miles and years raises questions about how such specialized knowledge might have spread. While these similarities do not conclusively prove direct contact between ancient civilizations, they do suggest the possibility of shared knowledge or parallel development of advanced building techniques. Ongoing research continues to uncover new connections, challenging our understanding of ancient cultural interactions and technological diffusion. Sacred geometry is the study of geometric patterns and proportions believed to hold spiritual or cosmic significance. This ancient practice combines mathematical principles with religious or philosophical beliefs, suggesting that certain shapes and ratios are fundamental to the structure of the universe. In the context of the Great Pyramids of Egypt, sacred geometry played a crucial role in their design and construction. The ancient Egyptians incorporated specific mathematical ratios and alignments that they considered sacred or divine. The most famous of these is the golden ratio, approximately equal to 1.618, which appears in various aspects of the pyramid's dimensions. The Great Pyramid of Giza, in particular, showcases remarkable geometric precision. Its base forms a nearly perfect square, and its height relates to its base in a ratio that closely approximates pi. The pyramid's angle of inclination is precisely 51.84 degrees, allowing its faces to form perfect equilateral triangles when bisected corner to corner. Furthermore, the pyramid's alignment with celestial bodies demonstrates the Egyptians' advanced understanding of astronomy and its integration with sacred geometry. The Great Pyramid's sides are aligned almost exactly with the four cardinal directions, and certain shafts within the pyramid point to specific stars that held religious significance in ancient Egyptian culture. The golden ratio, a mathematical concept found throughout nature and art, appears to be present in the design of the Great Pyramid of Giza. This ancient wonder, built around 4,500 years ago, continues to astound researchers with its precision and mathematical properties. When we examine the dimensions of the Great Pyramid, we find that the ratio of its slant height to half its base length is remarkably close to the golden ratio. This relationship suggests that the ancient Egyptians might have intentionally incorporated this harmonious proportion into their monumental structure. Furthermore, the angle of the pyramid slope is approximately 51.8 degrees, which closely aligns with the angle created by the golden ratio. This particular angle allows the pyramid to rise with a proportion that is visually pleasing and mathematically significant. While some scholars debate whether the inclusion of the golden ratio was intentional or coincidental, its presence adds another layer of intrigue to this already fascinating structure. The incorporation of such precise mathematical concepts in ancient architecture speaks to the advanced knowledge and skill of the pyramid builders, leaving us to marvel at their achievements millennia later. The number pi appears in the dimensions of the Great Pyramid of Giza in a way that has intrigued mathematicians and historians for centuries. The ancient Egyptians who built this colossal structure may not have explicitly used pi in their calculations, but the proportions of the pyramid reveal a remarkable connection to this fundamental mathematical constant. The relationship becomes apparent when we examine the ratio between the perimeter of the pyramid's base and its height. If we take the perimeter of the base and divide it by twice the height, the result is astonishingly close to pi. This suggests that the pyramid's proportions embody the concept of squaring the circle, a mathematical problem that fascinated ancient geometers. Some researchers propose that this correlation might indicate advanced mathematical knowledge among the ancient Egyptians, possibly even an understanding of pi long before it was formally defined. However, others argue that this could be a coincidence resulting from the practical methods used in the pyramid's construction, such as the use of a wheel to measure distances. Regardless of whether the inclusion of pi was intentional or not, the presence of this mathematical constant in one of the world's most iconic structures continues to spark curiosity and debate. It serves as a testament to the enduring connection between mathematics and architecture, bridging the gap between ancient wonders and modern scientific understanding. The ancient Egyptians were keen observers of nature and the human form, incorporating these observations into their monumental architecture. The Great Pyramid of Giza, one of the most iconic structures in human history, demonstrates a fascinating connection to human body proportions. The pyramid's dimensions reflect the golden ratio, a mathematical concept found throughout nature and considered aesthetically pleasing to the human eye. This ratio, approximately 1.618 to 1, is seen in the human body, such as the relationship between the length of the forearm to the hand. Interestingly, the height of the Great Pyramid, multiplied by 1 billion, corresponds closely to the average distance from the Earth to the Sun. This cosmic scale mirrors how the human body can be used as a measuring tool, with units like the cubit based on forearm length. The pyramid's slope angle of about 52 degrees is similar to the angle formed by a human hand when the fingers are spread wide. This angle allows for optimal stability in the pyramid structure, much like how it provides balance and dexterity in the human hand. These connections highlight the ancient Egyptians' profound understanding of proportion and their ability to translate human-scale observations into monumental architecture. The ancient Egyptian pyramids have long fascinated people with their impressive scale and precision. However, it's important to clarify that there are no definitively proven sacred symbols encoded in the geometry of the pyramids. Many theories and speculations have been proposed over the years, but these are not supported by mainstream archaeological evidence. The design of the pyramids was primarily driven by practical and symbolic considerations related to ancient Egyptian religious beliefs and construction techniques. The pyramid shape itself was likely chosen as a representation of the primordial mound from which the Egyptians believed life arose, and as a means to help the pharaoh's soul ascend to the afterlife. Some researchers have noted interesting mathematical relationships in the proportions of the Great Pyramid of Giza, such as its incorporation of the golden ratio and its alignment with cardinal directions. However, these features are more likely the result of advanced engineering and astronomical knowledge rather than hidden symbolic codes. While the pyramids certainly hold great cultural and historical significance, it's crucial to approach claims of encoded sacred symbols with skepticism and rely on well-established archaeological findings rather than speculative theories. The ancient Egyptians built their pyramids with remarkable precision, incorporating celestial alignments and mathematical ratios that reflected their understanding of the cosmos. These massive structures were not just tombs, but powerful symbols connecting the earthly realm to the heavens. The Great Pyramid of Giza, in particular, demonstrates this cosmic link, Its four sides align almost perfectly with the cardinal directions, showcasing the Egyptians' advanced astronomical knowledge. This alignment allowed the pyramid to act as a giant sundial, casting shadows that marked the solstices and equinoxes, important events in the Egyptian calendar and religious life. The pyramid's slope angle of approximately 52 degrees is thought to represent the rays of the sun touching the earth. This angle allowed the pharaoh's spirit to ascend directly to the realm of the gods. The smooth, angled sides of the pyramid were seen as a stairway to the sky, facilitating the ruler's journey to the afterlife. Interestingly, the proportions of the Great Pyramid also encode the golden ratio, a mathematical concept found throughout nature. This suggests the Egyptians saw their monuments as microcosms of the universe, embodying the same divine order they observed in the stars and natural world. Through these geometric and astronomical features, the pyramids served as a bridge between earth and sky, reflecting the Egyptians' complex cosmological beliefs. The Great Pyramid of Giza has long fascinated researchers with its remarkable precision and mathematical properties. One of the most intriguing aspects is the apparent presence of the mathematical constant pi in its design. The ratio of the pyramid's perimeter to its height is very close to 2 times pi, suggesting a sophisticated understanding of this fundamental constant by the ancient Egyptians. Another significant mathematical relationship found in the Great Pyramid is the golden ratio, also known as phi. This ratio, approximately equal to 1.618, appears in various proportions within the pyramid structure. Some researchers argue that the ratio of the length of the face slant height to half the length of the base side closely approximates the golden ratio. It's important to note that while these mathematical constants are indeed present in the pyramid's measurements, there is ongoing debate among scholars about whether they were intentionally incorporated or are simply coincidental. Some argue that the ancient Egyptians deliberately encoded these mathematical principles into their design, while others suggest that these relationships emerged naturally from practical construction methods. Regardless of intent, the presence of these mathematical constants in such an ancient and monumental structure continues to inspire awe and curiosity. The precision and sophistication of the Great Pyramid's design serve as a testament to the advanced knowledge and skills of the ancient Egyptian civilization, sparking ongoing research and speculation about their mathematical and architectural capabilities. The geometry of the pyramids has long fascinated researchers and enthusiasts, sparking comparisons with sacred sites across the globe. Many ancient structures, from Stonehenge in England to the temples of Angkor Wat in Cambodia, share intriguing geometric principles with the Egyptian pyramids. One common feature is the use of precise angles and alignments. The Great Pyramid of Giza, for instance, is aligned almost perfectly with true north, a feat replicated in structures like Chichen Itza in Mexico. This suggests a sophisticated understanding of astronomy and geometry among ancient civilizations. The use of the golden ratio, a mathematical concept found in nature, is another shared characteristic. This ratio appears in the dimensions of the Great Pyramid and is also present in the layout of sacred sites, like the Parthenon in Greece and certain Mayan temples. Some researchers propose that these similarities indicate a shared knowledge base or cultural exchange among ancient civilizations. However, it is important to note that many of these connections remain speculative, and further archaeological evidence is needed to substantiate such claims. Nonetheless, the geometric precision found in these diverse structures continues to inspire wonder and curiosity about the capabilities of our ancient ancestors. The ancient Egyptians demonstrated remarkable precision in pyramid construction, hinting at sophisticated geometrical understanding. The Great Pyramid of Giza, built around 4,500 years ago, showcases this expertise. Its base is almost perfectly square, with sides differing by mere centimeters over lengths, exceeding 230 meters. This level of accuracy suggests the use of advanced surveying and alignment techniques. Furthermore, the pyramid's faces are aligned with the cardinal directions with astonishing accuracy, deviating by only a fraction of a degree. This alignment required precise astronomical observations and calculations. The pyramid's slope angle of approximately 52 degrees is consistent across all four faces, indicating a standardized design and execution process. Internally, the Grand Gallery and various chambers exhibit precise right angles and parallel surfaces. The descending and ascending passages maintain consistent angles throughout their length. These features point to a deep understanding of geometry and its practical applications in large-scale construction. Recent studies have also revealed the possible use of the golden ratio in the pyramid's design. This mathematical concept, found throughout nature, suggests the ancient Egyptians may have incorporated advanced mathematical principles into their architectural plans, further supporting the idea of sophisticated geometrical knowledge in pyramid construction. The ancient Egyptians incorporated complex geometric principles into the design of their pyramids, reflecting their deep understanding of mathematics and astronomy. These precise measurements and alignments served both practical and spiritual purposes in their culture. The pyramid's shape itself was seen as a representation of the primordial mound from which all life emerged, according to Egyptian mythology. This connection to creation imbued the structure with profound spiritual significance. The smooth, angled sides of the pyramid were thought to act as a stairway for the pharaoh's soul to ascend to the afterlife, joining the gods among the stars. Interestingly, the pyramids were aligned with remarkable accuracy to the cardinal points of the compass, with the entrance typically facing north towards the pole star. This alignment was believed to connect the earthly realm with the cosmic order, allowing the pharaoh's soul to navigate the night sky. The pyramid's apex pointed directly to the heavens, serving as a conduit between the mortal world and the divine realm. The proportions and angles used in pyramid construction also held spiritual meaning. The golden ratio, a mathematical concept found throughout nature, was incorporated into the design. This ratio was seen as a manifestation of divine harmony and balance, further enhancing the pyramid's role as a bridge between the earthly and the celestial. Archaeologists and engineers have conducted several fascinating experiments to uncover the secrets of ancient pyramid construction. One notable project took place at Giza, where a team led by Mark Lehner and Zahi Hawass built a small-scale pyramid using tools and techniques available to the ancient Egyptians. They discovered that wet limestone blocks could be easily moved across the desert sand, challenging long-held beliefs about the difficulty of transporting massive stones. In another experiment, a group of construction workers in Mexico demonstrated how ancient Mesoamericans might have moved large stone blocks. Using ropes, wooden rollers, and leverage, they showed that a team of about a dozen people could move a multi-ton stone block with surprising ease. This method could explain how civilizations like the Maya transported materials for their step pyramids without the use of wheels or large draft animals. French architect Jean-Pierre Houdin proposed a theory that the Great Pyramid of Giza was built from the inside out using an internal ramp. To test this idea, researchers used infrared thermography and computer simulations to scan the pyramid, finding evidence that supports Houdin's hypothesis. This modern approach to studying ancient structures showcases how cutting-edge technology can shed light on age-old mysteries. These experiments not only provide insights into the ingenuity of ancient builders, but also challenge our assumptions about the limitations of early engineering. By recreating these techniques, researchers continue to unravel the complexities of pyramid construction, offering a deeper appreciation for the skill and resourcefulness of our ancestors. Attempts to replicate ancient stone cutting and transportation methods have yielded fascinating insights into the ingenuity of our ancestors. Experimental archaeologists have made significant progress in understanding and recreating these techniques, demonstrating that ancient civilizations were far more capable than often assumed. In Egypt, researchers have successfully quarried and moved multi-ton limestone blocks using only tools and methods available to ancient Egyptians. They've shown that copper chisels, when repeatedly annealed and reshaped, can effectively cut through limestone. For transportation, they've used wooden rollers and sleds on lubricated surfaces, proving that teams of workers could move stones weighing up to 70 tons with relative ease. Similar experiments at Stonehenge have revealed how Neolithic people might have transported and erected the massive sarsen stones. Using a combination of sledges, rollers, and levers, teams have moved stones weighing up to 40 tons over considerable distances. These trials have demonstrated that with proper planning and enough manpower, ancient societies could indeed manage such monumental feats. In South America, researchers have explored Inca stoneworking techniques, successfully replicating the precise cutting and fitting of large andesite blocks. They've shown that a combination of bronze chisels, hammerstones, and abrasive sand could achieve the remarkably tight joints seen in Inca masonry. These experiments highlight the exceptional skill and patience of ancient stonemasons, challenging our perceptions of what was possible with pre-industrial technology. Modern attempts to build scale models of pyramids have provided valuable insights into ancient construction techniques and the immense challenges faced by Egyptian builders thousands of years ago. These experiments have shed light on the incredible ingenuity and engineering prowess of our ancestors. One key discovery from these scale models is the importance of precision in pyramid construction. Even small errors in alignment or leveling at the base can lead to significant deviations at the top. This understanding highlights the remarkable accuracy achieved by ancient Egyptians without the aid of modern surveying tools. Scale model experiments have also revealed potential methods for transporting and lifting massive stone blocks. Some researchers have successfully demonstrated techniques using sleds, ramps, and levers that could have been employed by ancient builders. These models suggest that with careful planning and a large workforce, it would have been possible to construct pyramids using technologies available at the time. Furthermore, these modern attempts have given us a deeper appreciation for the organizational skills required to coordinate such massive building projects. The logistics of managing materials, labor, and construction stages become apparent when working even on a smaller scale, emphasizing the sophisticated planning abilities of ancient Egyptian society. Computer simulations have revolutionized our understanding of ancient construction methods, offering unprecedented insights into the techniques used by our ancestors. These powerful tools allow archaeologists and engineers to test theories and recreate building processes without the need for physical experimentation. One significant contribution of computer simulations is in unraveling the mysteries of pyramid construction in ancient Egypt. By modeling the movement of massive stone blocks, researchers have explored various theories on ramp systems and lifting mechanisms. These simulations have demonstrated the feasibility of using wet sand to reduce friction when moving heavy stones, a technique that aligns with ancient Egyptian technological capabilities. In Mesoamerica, computer models have shed light on the construction of Mayan temples. Simulations have helped researchers understand how these massive structures were built on unstable ground, revealing sophisticated foundation techniques that prevented sinking and collapse. These models have also illustrated how ancient builders might have transported and positioned large stone blocks with limited manpower and basic tools. Beyond individual structures, computer simulations have allowed archaeologists to reconstruct entire ancient cities. By incorporating data on available materials, terrain, and known construction techniques, these models provide a comprehensive view of urban development in civilizations like ancient Rome or the Indus Valley. Such simulations not only reveal construction methods, but also offer insights into city planning, resource management, and the daily lives of ancient peoples. Experimental archaeology has been instrumental in unraveling the mysteries of pyramid construction. By recreating ancient building methods, researchers have gained valuable insights into the techniques and tools used by ancient Egyptians. One significant experiment involved moving and placing large limestone blocks. Teams of workers used wooden rollers and sleds, demonstrating that relatively small groups could transport massive stones with surprising efficiency. This practical approach helped debunk theories that relied on advanced technology or extraterrestrial intervention. Experiments in quarrying and stone cutting have also proved enlightening. Using copper chisels and bronze saws with quartz abrasives, archaeologists have replicated the marks found on ancient pyramid stones. These trials showed that seemingly primitive tools were capable of precise stonework when wielded by skilled craftsmen. Ramp construction has been another focus of experimental archaeology. By building scale models and full-size segments, researchers have tested various ramp designs proposed in ancient texts and modern theories. These experiments have helped identify the most plausible methods for moving stone blocks up the pyramid during construction, shedding light on the ingenuity of ancient Egyptian engineers. Studies of ancient quarries have provided crucial insights into the methods and materials used in pyramid construction. Archaeologists and geologists have examined quarry sites near the Great Pyramids of Giza, revealing a wealth of information about the ancient Egyptians' engineering prowess. These investigations have shown that the limestone blocks used in pyramid construction were primarily sourced from nearby quarries. The ancient builders carefully selected and extracted stone blocks, leaving behind clear evidence of their quarrying techniques. Tool marks on quarry walls and discarded stone fragments have allowed researchers to reconstruct the extraction process, which involved using copper chisels, bronze saws, and wooden wedges to split the rock. Analysis of the quarried stone has also shed light on how the ancient Egyptians transported massive blocks to construction sites. Researchers have identified ramps and slipways that facilitated the movement of stone from quarries to building areas. This evidence supports theories that the pyramid builders used a combination of sledges, rollers, and lubricated surfaces to move heavy blocks over considerable distances. Furthermore, quarry studies have revealed that the ancient Egyptians possessed advanced knowledge of geology, enabling them to identify and utilize different types of stone for specific purposes within the pyramid structure. This understanding has deepened our appreciation of the skill and planning involved in these monumental construction projects, demonstrating that pyramid building was a complex and well-organized endeavor requiring extensive knowledge and resources. Archaeologists and researchers are employing cutting-edge technologies to unlock the secrets of ancient construction techniques. Ground-penetrating radar allows scientists to peer beneath the surface without disturbing archaeological sites, revealing hidden structures and providing insights into foundation methods. This technology has been particularly useful in mapping out entire cities buried under centuries of soil. Laser scanning and three-dimensional modeling have revolutionized the study of ancient architecture. These tools create highly detailed digital replicas of structures, allowing researchers to analyze construction techniques with unprecedented precision. By examining the virtual models, experts can identify tool marks, measure minute details, and even simulate how buildings were assembled. Spectroscopic analysis is shedding light on the composition of ancient building materials. This technique helps researchers determine the origin of stones and other materials, providing clues about trade networks and resource management in ancient societies. Additionally, it can reveal information about pigments used in decorative elements, offering insights into artistic techniques and cultural preferences. Artificial intelligence and machine learning are being applied to vast datasets of archaeological information, helping to identify patterns and connections that human researchers might miss. These technologies can analyze thousands of artifacts and architectural features, recognizing similarities in construction methods across different sites and time periods, and potentially uncovering lost building techniques that were once widespread. Experimental archaeology has significantly enhanced our comprehension of pyramid construction techniques. By recreating ancient tools and methods, researchers have gained valuable insights into the ingenuity and skill of ancient Egyptian builders. These practical experiments have shed light on the efficiency and effectiveness of copper chisels, bronze saws, and wooden rollers and sleds used in quarrying, transporting, and placing massive stone blocks. One notable discovery from these recreations is the effectiveness of wetted sand in reducing friction when moving heavy objects. Researchers found that by pouring water in front of a sled carrying a heavy stone block, they could reduce the number of workers needed to pull the sled by up to 50%. This simple yet brilliant technique likely played a crucial role in transporting the enormous limestone blocks used in pyramid construction. Furthermore, attempts to recreate ancient leveling and surveying tools have revealed the remarkable precision achieved by Egyptian builders. Modern recreations of plumb bobs, set squares, and water levels have demonstrated how these simple yet effective tools enabled the construction of near-perfect right angles and level surfaces across vast distances. These experiments have deepened our appreciation for the ancient Egyptians' advanced understanding of geometry and engineering principles. Through these hands-on recreations, researchers have also gained a better understanding of the organization and logistics required for such monumental projects. The insights gained from experimental archaeology continue to challenge and refine our theories about pyramid construction, providing a more nuanced and accurate picture of this extraordinary feat of ancient engineering. Unfinished pyramids in ancient Egypt have provided archaeologists and historians with valuable insights into the construction techniques and planning processes of these monumental structures. These incomplete projects serve as frozen moments in time, allowing researchers to examine the various stages of pyramid building. One key revelation from studying unfinished pyramids is the use of accretion layers in construction. This method involved building the pyramid from the inside out, with blocks laid at an inward slope. This technique ensured stability during construction and allowed work to progress even as the outer layers were being added. Unfinished pyramids have also shed light on the tools and technologies employed by ancient Egyptians. Traces of ramps, levers, and other devices used to transport and position massive stone blocks have been found at these sites. These discoveries have helped experts reconstruct the ingenious methods used to overcome the engineering challenges of pyramid construction. Furthermore, incomplete pyramids have revealed information about the organization of labor and the planning involved in these massive projects. Evidence suggests that skilled workers were divided into specialized teams, each responsible for specific tasks. This division of labor highlights the sophisticated management systems in place during ancient Egypt's Old Kingdom period. Modern engineering principles have revolutionized our understanding of ancient construction techniques, shedding light on the ingenuity of our ancestors. Advanced computer modeling and simulation tools now allow researchers to recreate and test ancient building methods virtually, providing insights into how massive structures like the pyramids or Stonehenge were constructed. One key application is in structural analysis. Engineers can now calculate the stresses and loads on ancient buildings, helping to explain how they have survived for millennia. This has revealed that many ancient builders had an intuitive grasp of complex engineering concepts, even without formal mathematical knowledge. Material science has also played a crucial role. By analyzing the composition of ancient mortars, concretes, and other building materials, we have discovered that some ancient formulations were remarkably sophisticated. For example, Roman concrete has proven to be more durable than many modern mixtures, leading to efforts to recreate these ancient recipes for use in contemporary construction. Geotechnical engineering principles have been applied to understand how ancient cultures managed to transport and erect massive stone blocks. This has led to theories about the use of sledges, ramps, and levers, which have been tested through practical experiments. These studies have demonstrated that ancient builders were capable of remarkable feats using seemingly simple tools and techniques, challenging our perceptions of technological progress.